computer. Okay, sorry. I think that I have an Alzheimer. Every day I should remind myself things that I had done the day before. So the today's session is devoted to electronics. We have a very nice talks contributions from Germany, from Esslingen University, from Art, from Jürgen, that they are among us. We have a contribution from Jonathan Westlake from Staffordshire regarding the best tools for ICT. And also we have a contribution from a colleague from the Technical University of Sofia regarding technology of micro and nano system teaching master students at the Department of Microelectronics. But we are going to start a little bit differently than today's theme, but very relative to what we have presented the first 2 days. So it's a great pleasure to have with us Pavla. I think she's not the first female speaker for our International Week. We have other impressive presentation from female scientists the first 2 days, but we are going to start today's session with something is related with soft skills again. So it has to do with social responsibility in engineering field, but Pavla is more expert on this, and she will present the outline of her presentation. Pavla has a PhD from the Technical University Liberec, Czech Republic, and currently she is a teaching staff in the same university in the Department of Administration and Management. More things Pavla will say. Pavla, thank you very much to be with us. Actually, Pavla is next to me. Is the first speaker that dares to approach me in a distance smaller than 3 meters, but longer than 2 meters, which is the safety. So Pavla, let me give you sharing options. And now you can share your screen and present yourself. Thank you very much, Pavla. And I will mute myself, and then you should unmute yours.
So, can you hear me now? Yes. So, good morning, everyone. It's really a pleasure for me to be here and to have a lecture about CSR, about corporate social responsibility. First of all, let me introduce myself. Do you think? Oh, I will try. So is it better? Yep. Okay. So I will continue, and I would like to introduce myself first a little bit. As Kostas said, my name is Pavla, and I work at the Technical University of Liberec, where I have 2 part-time jobs. So the first one is at the Faculty of Economics, where I'm a teacher, and the second one is at the Institute of Nanomaterials and Advanced Technologies. So I combine the practice at this institute, and on the other side, I teach what I do there. You can see here where our university is. So it's close to Germany, it's close to Poland. It's about 100 kilometers to Prague. So we are in the heart of Europe, and we have a lot of cooperation with the other universities all around Europe. So what I'm going to talk about today, it's this content. First, I would like to start a little bit about CSR. What is it? About some terms we use there, a little bit about history and stakeholders. The main part will be devoted to CSR pillars. Some small talk will be about standards and implementation, and finally the communication. So that's the plan for my short explanation of CSR. So I would like to start with the definition. There's a lot of definitions of CSR. You can find them especially in English books, quite a lot of them. Very important for us now is that it's a voluntary tool. So it's not obligatory, and usually companies say, use it now as it is obligatory, but no, so far it's voluntary. And the base principle is, we call it like a chip bottom line. So there are three pillars. The first one is environmental, the second one is social, and the last one is economy. So we combine them together, and somewhere in the middle there is the sustainability, which is, as I think you know, very important for all of us. When we talk about CSR, we try to move from the view to the companies, from profit only to those three people, planet, profit. So again, there are those three pillars, and not only CSR is devoted to sustainability, but many other terms are used: code of ethics, corporate identity, image, citizenship, or responsiveness, which is a little bit more than just the responsibility. I think that you also know the shared value, or sometimes, or not sometimes, quite often are mentioned corporate governance, philanthropy, and so on. So not only CSR, but so many other terms are used. As I mentioned, sustainability and development, according to the United Nations, there are 17 goals described. And when you look at it, you can see that some of them are related to social area, some of them to economic, and quite a lot of them also to the environment, which is very important, especially for the companies which produce products. Here I would like to mention this quote from Antoine de Saint-Exupéry, that we don't hurt the air from our ancestors, but we borrow it from our children. So I think that all people should consider it and take it into account. When we talk about the history and about the basis of CSR, we have to mention R.G.B. Carroll and his pyramid. The problem or the principle is like in the other pyramids, you know, for example, the Maslow pyramid. So you have to start at the bottom, and then when you fill the bottom line, then you continue, and finally, sometimes maybe you are on the top. So this is the same principle here. And R.G.B. Carroll was the first one who described this well. But on the other side, from the history, the important man I would like to mention is Howard Bowen. And his book, he described their CSR not from the company's point of view, but from the point of view of individuals. But we may say that he's the father of CSR. The next one was Keith Davis and his Iron Law. And again, R.G.B. Carroll and his pyramid. So you can saw it a while ago. In the 19th, there was a quite huge EU involvement, especially the involvement of Jacques Delors, the president of the European Commission, who started to promote CSR on the EU level. So some networks were established, the national social and responsibility centers within the European countries. So I think it was the first impulse to spread it all around the world. Then the Green Paper came and the Lisbon Strategy. So again, there were mentioned all those three areas: social, economic, and environment. And the Europe Strategy 2020, that people should, not only people, but the companies should achieve the economic growth based on those three economic, social, and environmental topics and pillars. Here I would like to mention our Czech, very important entrepreneur. His name was Tomáš Baťa. Maybe you know him because of his shoes, very famous, not only in Europe, but all around the world. And his principle of management theory was in those times very interesting because he managed the principle of decentralization. He decided about the profit participation of the employees. So it was the motivation for the employees, the work moral. He planned the production in a little bit different way than the others do that. So from this management point of view, it was very important and very interesting, and especially about also his social policy. He took care of his employees from the nutrition point of view, healthcare. He wanted to prepare the good condition for his employees also from in their vacation and leisure time. So finally, it was a pity because he died quite young within the air crash, but his companies and his branches are now all over the world. I would like to mention here two his quotes. The first one, if you give a fish to a human, you will help him for one lunch, but if you give him a rod and teach him how to catch the fish, then you will help him to get and arrange the whole life. So I think it's very important. And nowadays, thinking to people, hard work for machines. I think you are specialist in ICT technologies and engineering. So this topic is your topic. So I think that you agree with me and also with him. But there was the Second World War, totality, communism, and things like this. So he couldn't continue in his way, and it was changing a little bit. But we may say that he was very, very popular, and his way of thinking was exceptional. The next, I would like to mention our stakeholder, because when you talk about and when you think about CSR, you usually use this term. Someone would like to ask something? So we may say that all people around the companies producing the services or products are stakeholders, and it depends which part or which group you will define. So we may distinguish primary and secondary stakeholders. So the primary are owners and investors, employees, customers, business partners, so really close to your company. Secondary stakeholders are all around, like public, government institution, media, competition, and so on. So the very important for each company is to say, okay, these are my stakeholders. I have to focus on this or on that groups. So it's impossible, like when you are doing marketing, you have to focus just on some targeted group. The same it is with this topic and with CSR. So you have to choose who are your stakeholders and who will be all around your company. So first you have to identify them, the project, the resources you need. Then you do all the analysis and implement them for your strategy. Finally, you will monitor the internal and external changes, what happened, what may happen, what failed. So again, the analysis, and finally, you will monitor the satisfaction. How was it, or maybe wasn't. So these stakeholders are very important for you. The involvement of them may be different. Usually very popular are questionnaire surveys, but today it's not so easy. So the online discussion forum are popular. different working groups or meetings, formal, informal. Sometimes it's better to go somewhere for any informal meeting and to discuss things together. So not everyone is prepared for directly or for direct communication. So through these informal meetings, it could be a way how to see the differences and to find the right questions and answers. To the pillars, I said that it will be the main part. So I will shortly just talk about the internal social pillar. Again, there is a lot of tools. Maybe I could say that this CSR problematic is a really rich topic. So for me, it's for the whole semester to teach the students what to do, how to do that. So this is just a really brief information for you to know about it a little bit more. So the social policy instruments may be distinguished by the duty, like compulsory social, contractual social policy, or the voluntary social policy. Again, it depends on the law, on the collective agreements. By size, individual services or group services. So again, it's connected with the stakeholders you had already defined. So who will be your, we may say, customer? By distribution methods for all of them or just the targeted group. I mentioned here the US system, cafeteria system. So it's not about the coffee, but it's a system when you try to find the best condition and but motivation for your employees to be satisfied. So again, there are several systems how you can implement it and establish it in your company. The first one is the core system. So the benefits offered are divided into fixed and optional parts. The second possibility is the buffet system. So there are some limits of the employees according to their budget or their preferences. And the last one is the alternative menu system, where there are personalized some benefits and there are several blocks and that the employees can just choose one of them. So it depends on the policy of the company. Of course, there is a black and white situation again, advantages, disadvantages of the system. So what are pluses? It contributes to motivation of your workplace. The employees become more responsible, more loyal. Usually they get more or for less. And of course, there are some business principles of this support. On the other side, the black side, the disadvantages. First of all, the implementing. You need to find people who are able to establish this system, to implement it within the company. It's administrative demanding, quite expensive, it may be. So sometimes it's not so easy. The unwillingness of employee to adopt something new when there is something running in the company for several years and finally someone from the management, the managers say, okay, we will change something. You know that not only within the university, but also within the companies, it's not so easy to change something from one day to another day. So the unwillingness may be very important, and the disadvantages. The communication, again, not just only within the universities, but also within the companies. I think it's a very important tool to change something. So it could be a big problem. So here's just a short summarization of all the activities and tools within this internal social pillar. So you can see that it's up to the managers, up to the company, what they would like to do, how they would like to do. The external part, the second one, so supporting the surroundings of the community. For example, the corporate philanthropy, the tools like financial contribution, gifts in kind, and the others. So it's again the voluntary, what they would like to do, if they would like to do something. So there's a lot of possibilities. So I would like to mention just in these terms, the volunteering matching fund. I think that maybe you know it, CRM, so the course-related marketing, and many, many others. But again, it depends on the company. And here just again, in shortly form the table with terms and activities, what can be done. So it was about the social bill. For the companies, I think very, very important nowadays are the environmental activities and this area. So within this, and in this connection, we talk about the EMS, this environmental management systems. I think that the objective is clear, to protect the sources, to reduce the pollutant emissions, to reduce all the environmental risks, and try to protect the health of the employees. The tools could be the standards. So I mentioned here ISO 14001. Eco mapping, I think nowadays it's very popular to prepare the maps and to identify the problems where it can be and how can we change it. The next tool can be the environmental friendly products with this EU label, for example. So again, it's up to the company, and they can try in which way they would like to go. I'm sure that you know this PDCA cycle when you compare the time and the quality, and you try to do it again. You plan something, do it, check it, act, and finally you will see that something is getting better. So you continue, and the quality of your services, of your products, of your management should be better and better. So in this idea, it should work. Again, DMS, like the whole CSR, is the voluntary tool, and there are two ways how it can be implemented. The first one are international standards, ISO series, or the eco management and audit chain. But there are some differences, and sometimes it's not so easy for the companies to choose the EMAS or the ISO. So here are the differences, the main differences I found. EMAS is a public accreditation, but ISO is the private one certification. EMAS is valid in the EU, but the ISO is valid worldwide. So maybe for the international companies, it's much more better. The EMAS provides public information of outputs, but the ISO doesn't do that. There is a large number of requirements for the enterprise. So sometimes it's for small or medium enterprises a little bit demanding or not so easy to establish it as the ISO. And the last one, that EMAS is not yet widespread among the companies so much as the ISO is. Some statistics, so maybe I hope it's quite interesting for you, because you can see that within the last half year, 6 months, there were almost 100 new organizations registered in this EMS system. You can see that most companies are from for Spain and from Italy. And here is a table that more than 3,600 organizations are involved in this project, or not project, in this system to April of this year. Most of them are from Germany, following by Italy and Spain. So this is to the numbers, and this is a chart devoted to the area of the production. So according to the classification of NACE, so you may see that most of the companies are specialized in construction activities, but it depends again on the countries. And how does it look like with the statistics of size of the companies? So you can see that there are not so much differences between the small and large companies. Yes, there are some, but not such a big difference. So I think it's not about the size of the company, but it depends on people, on the management who is in the top. Again, some teams, activities connected to this environmental area and this pillar. So I mentioned above all the policies like ISO and the EMAS system, but there is a lot of other activities which can be done. Here I would like to mention, it's not devoted to the companies, it's devoted to individuals, I would say, because on this link, you can calculate your carbon footprint. So when you click on it, you will see the web pages where you can find your language, and you can calculate what is your personal carbon footprint. So I think it's quite interesting for all of us just to imagine how does it look like with your personal life. But the last is the economic pillar. So it's really about the money, because the main target of each company is to produce the profit. But not only this target is now very popular or not so important. Very important are also activities devoted to developing and adhering to a code of ethics. You see or you hear quite often about transparency and a responsible approach to the customer, which is very important. Building relationships with suppliers on the other side. So if you would like to produce the product the customer needs, then you need to get suppliers with the highest quality, providing clear and accurate product service information, and so on. So I think I will not read this, and I will continue with the standards devoted to CSR. The last one, the newest one, is ISO 26000. It's about the implementation of CSR, social accountability, ISO devoted to the protect health of the employees. EMAS, I mentioned, ISO 14001. So, but it's not only G standard, but there is also, it's within this topic, investors in people, but it's again voluntary principle or standard, or depends again on the managers. But generally, we may distinguish all these three pillars or areas, and each standard is devoted to each area. So ISO is comprehensively about CSR, social pillar, and environmental pillar. I mentioned ISO and EMAS. So These are the main standards what you can find, but also the others. The implementation, I mentioned here again the PDCA cycles. So first you have to plan what are you going to do. You, as I mentioned, have to identify your main or key stakeholders, the primary, the secondary. And then you should set your values, your principles, analyze it. How does it look like now? What is your mission? What is your vision for the current future? Set your objectives, your goals, your CSR approaches, and then you are ready to have an action plan and to implement it within your company. If all the employees are ready for it, then it may take just several, for example, weeks, months. But if the company is large enough and you have to communicate it a lot, then it will be a longer time. If you implement something, then you have to monitor it, report it, and you will see how does it work or if there are some problems.
Трябва да запишем и тия данни.
So you have to continue and try to improve your quality and start, we may say, again. I mentioned there the communication, because communication monitoring and responsive reporting is very interesting and very useful for CSR. And you can use so many tools, sometimes not in our country, but I think all over Europe, the annual reports are obligatory. So you report something, and sometimes the companies don't say, okay, this is our CSR report, this is the report about our activities, about our economic situation, about social and environment. Sometimes it is announced as a CSR report. So it depends on the country, but this report, I think, is the main tool. And if company produce something like this, then they say, okay, we are on this level, this is our PR, and we present ourselves as the company which is responsible for the environment. The other tools may be internet or some newsletters, magazines. Code of ethics, I think it's also obligatory within all of the companies. Open days when it's possible to meet people, not nowadays, but I hope that next year it will be again popular to open your companies and to public how you produce your products, how you serve your services, shared marketing, and so on. But again, I would like to say that the main is the CSR report. The advantages, I would say the first one is transparency, improving the image. Of course, you strengthen your relationships. The employees are usually more satisfied and motivated to do their best job in your company. Cross-sectoral cooperation, also new business opportunities. It's connected with the innovation, so I think it's a really good idea. Finally, I would like to mention some arguments for and against CSR. The first, with the question mark, it increases profits. It depends, because you produce your products, sell them, and you would like to get the profit. And if you sell not only your products, but also the idea of sustainability, then I think you get more, not only the profit when you can see it in your money, in your accounting. You can get access to the additional capital. So it's about the cooperation, about the communication. You may reduce your costs because your proactive attitude. You just don't stay and wait for what happened in the future, but you are proactive and you try to be first on the market. You try to innovate your product, your services. You try to find the new sense, for example, of your products or services. And this way you may reduce your risk and risk management costs. But again, nothing is only white, but the argument against CSR were mentioned by the economist, the classic economist Milton Friedman, who said that it restricts the main classic economic goal, which was the profit maximization. So he was against this principle. And the next argument may be that CSR suppresses the primary purpose of business and ultimately free market, so the global marketplace. It may be also the view of this concept, but I think that there are more positive arguments for this concept, and I think that the companies should follow this concept, and I think that now it's voluntary, but in the future it will be obligatory because of the sustainability all over the world. So it was really briefly about this concept. Thank you for your attention, or if you have any questions, you can ask me.
Thank you very much, Paula. I think that you should mute your microphone. We're very close with Paula. That's why we have this second. So, okay. Thank you, Paula. Thank you very much for your presentation. I think that it comes and fits very well with the first presentation that we have here in the International Week from Thomas Ajax. Actually, this happened on the frame of the Sci Cafe, and it was like, let's say, we can say the startup of our International Week. I don't know if there are any questions from the audience. I mean, if you stop sharing your screen also. I have one question that I think is very essential. I was expecting this to be asked by someone with management positions. You know, the main issue that we face in the universities, I mean, this is my perception, of course, is like how to look. I mean, I cannot be focused on the presentation since the people are coming, you know, whenever they want. But I will find a solution for this. The main motivation, the main problem, the main challenge that we face in the universities, and I repeat, this is my perception, is like how to motivate people to do something extra from their fixed duties. You know, the people, they would like to do like 1, 2, 3 things, the majority of them. And if you ask them something extra, they don't do it, or they don't participate, or I mean, they have a mentality, okay, I'm getting paid this money for these specific duties, and in the best of the case, they are just doing these duties. I'm not going to be too bad. So what are, you know, from the management theory, what are some motivation, like some tips in order to push the people to do something extra? For example, I would like to thank also Yanis Vardiabas for his kind words yesterday, but it's not only this. Probably Yanis will agree with me. Petrakis is here, my colleagues like Maria Zakinthinaki, or probably I have seen, you know, Ioannis Kaliakatsos. But it seems this is an example that the people, they don't participate. I can see this since 2006. Like that we organize these summer schools, like, okay, and then the result comes like European University, everyone appears in the result, but they had the chance to participate in so many events. But I'm not accusing them, but they don't participate because they have other things, or they don't want to do the extra thing. I don't know. I mean, so the universities, they don't operate. I don't know how is the private in the market world. They don't. I mean, they don't do an extra move, an extra. Okay, sorry, I have to mute the people as well. They don't do the extra thing. So how we can motivate them? I mean, I like your idea, and I think that we should keep on the mind the open days, but open days not only for our students, but for our colleagues as well, to start the semester and say to them, like, for the next semester, we are going to plan and we are going to do these things. I mean, what is your opinion? You are Jesus Christ. Okay, what is your opinion on this?
Yeah, I know it's a big problem.
Just a moment. Now I should mute myself.
Yeah, I think it's a big problem because maybe therefore it's just so far the voluntary tool, not the obligatory one. Because the people, not only in the university, but in all the companies, just see that they have these tasks, they have some money for that, they go home and they then have their lives. So I think the first idea is, or the problem is to change the mind of the people that there is not only one, they are not only there who are in the companies, in the towns, in the universities, but they also have their children and they would like to continue with their lives. And it's more maybe philosophic topic than the economic one. So there is no management tool or economic tool how we can tell them, okay, you have to do that or you can't do that. So it's inside them. And
so it just like to have an internal motivation to do extra things.
Yeah. To use not financial benefit, but to use not financial benefit, but also the non-financial
exactly.
cafeteria system. So as I mentioned, with the cafeterias, some other benefits you can offer them within their wages and salaries so far. And then they will realize, okay, I can change something and it will be better than that. That's only the idea, I think.
So I think that I will try the open days for my colleagues to check out how this will work, because in the department we are doing so many extra things, like from some colleagues. But I can see not only in my department, also in Heraklion in general, in the whole university, there is no, how can I say, the boost to become, because if you participate in this, they cannot think like you are going to become better in not in a short time, but not in a very long time. I don't know. I mean, this is something that plays on my mind, many years, and this question came, through your presentation. I don't know if Ioannis Vargiabas that also is like had a management and administration position. What is your perception? I mean.
Well, I think it is difficult to put people to do what they don't think it is good for them to do. Well, we have to persuade them with the good or the bad way. You know my opinions about the subject. Well, all is about how we can make people to understand what is best for the whole thing. We have a whole department, a whole university. And what now Kostas does is not just for Kostas, is for all of us. So we have to be there. Why are not here? Well, let's see.
But Yanis, this is not. Yeah, I mean, this is a part. You described. Part of the problem. It's not the problem to be here. It's a part like just to contribute with, not with their participation. I'm talking generally in all the universities, not only in us. I think that this is like, especially the European universities, they don't have this boost, to do more things and see the university like a company. So I'm not saying that university is a company, but they should operate like a company, to have a planning, to do new things for the students. Students is our, let's say, I cannot say these are our customers, but they are our customers. They should be satisfied, but also they should be trained, not only satisfied, because this is a different story. I don't know. I mean, thank you for the presentation, and this open days idea probably is the solution to propose in our university administration, at least us, in order to be the first and more flexible than the others. I don't know if there are other questions from the audience, from the students. Okay, if this is the case, I would like to. Oh no, I have another one because I'm keeping notes. You mentioned about environmental management. So I would like to ask you, what are the objectives of the environmental management? Okay, we are a university, and we would like to somehow to establish, and probably we have environmental management. It's like just our carbon footprint. I mean, what kind of lights are we using? How, if we have automations, and after we leave our offices, the lights will be shut down. Is this what are you talking about? Okay, all right. I can see her reaction because it's opposite to me. You cannot hear it, so I can see a head like ups and down, or you can see her face, on the cameras. This is like why we should have the cameras on. Body language is something that we are going to teach in soft skills. Okay, so thank you very much, Pavla. It was very nice to be with us, and even nicer to be next to us. All right. So thank you. And I think it's time to move to the next speaker. The next speaker comes from Esslink University. Personally, as an Erasmus coordinator, I had a very good impression about Esslink because last semester we had 3 very good Erasmus students from Esslink. Nikolaos Petrakis, not in our department, but in Heraklion. They were coming from the social work area. They were very disciplined. I mean, I'm not surprised. They are coming from Germany. I would like to give the floor to Arndt. He's going to speak and discuss something that I really like because it comes from my area, from photonics. And Arndt, the floor is yours in order to present yourself and present what are you going to discuss about. And please, Arndt, send me your presentation. It's very important to have all the presentations because the presentations, they are going to be uploaded and they will be shared with the people that probably they did not have the chance to follow your, I'm pretty sure, very interesting presentation.
Okay. Yeah. Thank you very much, Kostas. Thank you very much to the organizers for inviting me to this International Week. I hope, can you see my presentation?
You should share your screen.
Yes.
Okay, now it's fine.
Now it's fine.
Yeah, if you place it also to the full screen. Oh, fantastic, fantastic. Now it's fine. Sorry, the floor is yours.
Thank you. Yeah, thank you, Mr. Chairman. Thank you, Kostas, ladies and gentlemen. Good morning here in Kenya. And I'd like to talk about electric lights from conventional to solid state light sources. That's a matter that everybody can observe in its daily life. And so I'd like to bring some physical insights into that topic to you. Let me briefly outline my talk. First, I will give a motivation. And from that, you will see we have to talk about briefly about efficiency of light sources. And then in the second part, I will show you the different white light sources, which you probably also have seen already in life. And so these are especially the thermal light sources, fluorescent lamps, and then the new solid state light sources. I will talk about the operation principles and the applications. Yeah, and finally, I will give a summary to my talk. Yeah, the motivation is that if you look at the night sky atlas of the world, then you see that our life is bright and illuminated. And if you look by a closer look, you see that 20% of the world's energy resources is actually used for lighting. So saving energy resources requires continued efforts toward energy-saving lighting solutions. That means we have to look for for efficient light sources, and that fuels companies like Osram or Philips or Nichia, several big players in the world that try to develop better and better light sources. Here I can show you the efficiency history of lighting technologies. This is a compilation of data collected by Osram Opto-Semiconductors, where I was for a while, for several years as an engineer. And you see here plotted in a light source efficiency diagram versus the time in years. You see different light sources. For example, you see here the well-known incandescent lamp, which was originally introduced in 1879 by Edison and Goebel in the US. And so this incandescent lamp is not very efficient, as you see, but it is still in use today. And you also see that the efficiency didn't climb up further over the last decades, but it is still in use. Then another light source is the tungsten lamp, the halogen lamp, which is a little bit better in efficiency, but there is also not further development possible. Then, for example, in Esslingen, we have in the rooms, we have fluorescent lamps, those tubes, and they are quite efficient, up to 100 lumen per watt. That's actually the luminous efficacy. That's the proper name for it. And you can actually also fold this lamp into a light bulb form. Then it's called compact fluorescent lamp, and they are less efficient, but you can buy them today. Also, I've brought also one with me, and yeah, they are not that bad, but during the last, you see, 20 years or even 25 years, we have seen a tremendous development of new light sources, and this is especially the LED and also the OLED or OLED. It's an organic light emitting diode. So the LED is the anorganic light emitting diode. And you see the tremendous increase in luminous efficacy and efficiency during the last years. Today we have even in the lab more than 220 lumen per watt efficiency for white light sources. Yeah, let me discuss these 4 light sources in more detail. You see here a table that comprises or gives a summary on a rough summary of the main parameters of actually products of that you can buy in the supermarket. Yeah, the incandescent lamp has a wall plug efficiency and luminous efficacy. These are the efficiency values that I can roughly here provide. The wall plug efficiency is just 5%. Wall plug efficiency is how much power do you put electrical into that device and how much light you get, light power you get out of it. So essentially this product is essentially a heater 5% only of the light you can use, you can perceive by the eye, but 95% are essentially wasted and just heat. With a fluorescent lamp, it becomes better. It's 30%, approximately 30% wall plug efficiency. You see this luminous efficacy is 10 lumen per watt and 60 lumen per watt. Today, if you buy a lamp in Germany, then you find on the package the luminous efficacy values. Yeah. So, for example, a 60 watt incandescent lamp has approximately 700 lumen, and you know how much electrical power you put in, then you can directly calculate the lumens per watts. Sometimes even this value is written, especially for the white LEDs. So the white LEDs today that you buy, they have luminous efficacies of about 60 to 80 lumens per watt. That corresponds to a wall plug efficiency of 30 to 40%. So still, for white LEDs, we have about 50 to or 60 to 70% is wasted and goes into heat. So, and a very important argument to buy the white LED is, besides the efficiency, also the lifetime. Compared to an incandescent lamp, which has a lifetime of about 1,500 hours, the white LED has very long lifetime, 20,000, 30,000 hours. And you get it today in a supermarket for, say, about €2 or more, of course. Then there is, I go back to my last transparency. What we see here is that the OLED is just a few years, maybe 5 years behind the LED in time, but it follows the same trends and the same efficiency development. And today we have white OLEDs, which have also a luminous efficacy of 65 lumen per watt. That means a wall plug efficiency of about 30%, and also the lifetime is very high, but they are more expensive because it's still not a mass product. But if you want, you can. I recently bought an OLED for via eBay for €14. I have brought it with me. I can show you. I can show you that. Yeah, later, or well, yeah, maybe I show you this right now. Maybe here with I brought some lights with me, some bulbs, and so the typical light bulb, the incandescent lamp. You see, that's the small one here. You can, yeah, you see the second one. That's this one was the incandescent lamp, and this is the compact fluorescent lamp. It is larger because it has a driver included in this bulb, so it has a larger size. And you see also the LED lamp is also larger than the regular incandescent light bulb, because this has also a driver inserted, and because the LEDs actually they run at low voltage, and so you need a converter from 230 volts down to, say, about 4 volts. And if you touch them, if they run, then you immediately feel that the LED light is much becomes much less hot compared to the other ones. And the LED I also brought with me, that's this one here. That's an LED, an organic light emitting diode, sorry. This is produced for the automotive market. I will show you later the advertisement of Osram for that product. And this device is pretty large and thin and gives white light. Okay. So let me now come to the topic efficiency. How can we measure that, and how it is how is the efficiency defined? Here you see an experimental setup that we have at the University Esslingen. We use for the efficiency measurement an integrating sphere, which is connected to a calibrated spectrometer. And this integrating sphere is designed so that all the emitted light of the lamp or the LED is collected and is homogenized on the inner surface of this integrating sphere. And a part of that light is then coupled into the spectrometer and is detected. And with that, you are able to measure the optical power which is emitted by the lamp. If you have a proper calibration, and this is actually a typical industrial setup, then if it is calibrated, then you are able to calculate the wall plug efficiency by forming the ratio optical power, or it is actually called radiant power, Phi A, divided by the electrical power. For DC sources, it's simply the product of voltage times the current. And the resulting unit is then, of course, watts divided by watts. So you give this efficiency, for example, in percent. From that, from the wall plug efficiency, then you are able to calculate the luminous efficacy. It's actually calculated in the same way, but you now switch from, or you calculate the radiant power into the luminous flux phi V divided by the electrical power that you put into that device. And then you get the unit of the luminous efficacy, the lumens per watt. And this calculation from the radiant power into the luminous flux, I have to explain with the next transparency, because these two quantities are, the first one, the radiant power, is a radiometric quantity, and the luminous flux is a photometric quantity. The difference is that the luminous flux depends on the perception of the human eye. So there plays the V lambda curve, the spectral response of the human eye plays an important role. You know probably that the human eye has a maximum sensitivity at a wavelength of 555 nanometers in the green range, so chlorophyll. And in the UV and in the infrared region, we don't see any light anymore by the human eye. And if you can calculate the photometric quantities by convolution of the radiometric quantity with the spectral response of the human eye with this V lambda curve, as it is written here by this equation, and the factor Km, that's the maximum luminous efficacy of radiation. This is if you, that means you are here in the maximum at 555 nanometers in the green range, then the maximum luminous efficacy is possible of 683 lumens per watt if you have 100% efficiency. Yeah, okay. That for the about the efficiency, the measurement, and how you can differentiate between the luminous efficacy and the wall plug efficiency. Now let me come to the second part, which is the main part of my talk today. And I'd like to show you and discuss the different light sources, white light sources. And I start with the thermal light sources, such as the incandescent lamp. This is an electric light with a tungsten wire filament, which is enclosed in a glass bulb, and the wire is electrically heated up to about 2500 Kelvin. It's made from tungsten. Tungsten has a very one of the highest melting points, more than 3000 Kelvin is the melting point, and so you can drive it up to about 2500 Kelvin. And then the result is you get a broad emission spectrum, but the maximum is in the infrared, and as you know from the V lambda curve of the human eye, this infrared you don't see. So you see only a very small part of this broad emission spectrum by the human eye. Yeah, this is, you can explain the thermal light sources by the black body radiator. And Max Planck established the theory in the around 1900, which is very important for the beginning of the quantum mechanics, because he had to introduce the quantum of the quantum mechanics. And so the black body radiator absorbs all radiation that falls on it, and therefore it appears black. And it emits radiation which depends on its temperature. So you can imagine it's like an oven, and the inner walls of the oven, they glow. They are at a temperature, and the Stefan Boltzmann law of the radiant power phi gives the equation for calculating the radiant power. This depends on Stefan Boltzmann constant, on the area of the opening of the oven, and on the temperature. And the temperature, that's a power law to the power of 4. So the temperature is the main parameter here. So if you use, and Max Planck was able to establish a theory for phi, and by putting it into, by integrating it over all the wavelengths, he was able to show that this corresponds exactly to the Stefan Boltzmann law. And he was able to calculate all the spectra, which are shown here. That's theoretical spectra, and they fit very well to the known black body thermal radiators, thermal light sources. And you see here as a parameter all the different temperatures. At low temperature, the maximum is in the infrared, and if the temperature increases, then the maximum of the spectral function goes to shorter wavelengths. This is described by the Wien's displacement law, where lambda max, this maximum of the emission wavelengths, times the color temperature, times the temperature of that black body source is a constant with a specific parameter here. So an incandescent lamp is with a color temperature of 2500 Kelvin, has its maximum around here, around 1 micron wavelengths. And so we have there, you see a very broad emission spectrum and the emission maximum for the incandescent lamp in the infrared. Another example, it's not electrically, of course, but very prominent for us, the sun at the sky. It has a temperature of a color temperature of 5,800 Kelvin at the surface that we are able to see, and this means that there we have the spectrum is shifted to shorter wavelengths. The maximum is at shorter wavelengths, so that we can see it actually also better with our eyes. Okay, so let me go further. Next step to the fluorescent lamps briefly. The fluorescent lamps, they consist essentially of a glass tube, which is filled with low pressure gas. And typically you have quite an amount of mercury atoms inside. And under electrical operation, if you apply a high voltage, then electrons are accelerated in the gas, and the collisions of the electrons and the mercury atoms, they ionize further gas molecules, which are, for example, argon often is included also in the glass tube. And this process is called impact ionization, and the gas emits then light in the ultraviolet region of the spectrum. This ultraviolet emission of the gas ions has then to be converted into visible light by a fluorescent converter, which is positioned in the inner coating of the tube, so that you get a broad spectrum, because we want to get white light from that, and the eye sees white light from that broad spectrum if you do it properly. And yeah, it's quite an efficient conversion of electrical power into optical power. So it found a great broad application into general lighting. But there is a great concern about environmental issue we have with this mercury. And so probably in the next years, these tubes will be banned from the market. Okay, now let's come to the solid state light sources, and let me go first to the light emitting diode, the LEDs, and then afterwards to the OLEDs. An LED is basically a solid state device made from crystalline anorganic materials by a process which is called epitaxy. So these are single crystals, layer by layer, were grown on a single crystal substrate. And then from this, after that grows, a chip is built, a die, and it consists of a quite complex layer structure. Briefly, it consists of a p-n junction, and at the junction, under electrical operation, photons are generated. And for that, you need contacts, a back contact and a front contact. And then you can run electrical current through the device. And photons are generated, which are depicted here as the red beams. It works like the following. If you have no bias voltage applied to these contacts, that means under 0 voltage, then due to the doping, the N doping and the P doping, you have a band structure, an energy band structure of these semiconductor layers, which is these two doping regions are well separated by this junction, where you don't have any carriers. You see on the N doping part electrons, and on the P doping parts they are so-called holes. Under forward voltage, so with applying a voltage which is in the order of the energy gap of the semiconductor that you want to bring to the emission, so about 2 volts up to 4 volts, depending on the material that you are using. Then if you bring it to forward voltage, then the electrons and the holes can meet and can recombine. So the electrons have more energy compared to the holes, and they recombine spontaneously. And if everything is fine, then the light is emitted. There are several, actually, essentially 2 material systems which are today commercially important. These are the system gallium arsenide-based indium gallium aluminum phosphide, and the other system is indium gallium nitride. With these 2 systems, you are able to shift and move the energy gap to the proper range. And what you want is a certain emission wavelengths at the end. For example, here you see the red emission of a red LED, the green emission, the blue, and the ultraviolet emission. These are very narrow peaks. And so there are 2 approaches to make white light, because for white light, the eye needs some broad or something that it thinks it's white. And you need several, so you need several wavelengths in the emission, in the light. For example, you can make it by addition of red, green, and blue LEDs, or you use just a blue LED and put a converter, like in the for the fluorescent lamp. This converter you can use. You put that converter on that blue chip, and then you get a broad spectrum that is shown here in this diagram. And this is a typical spectrum of a single white light. Yeah, so this just to illustrate again the 2 important material systems. That's the indium gallium aluminum nitride system for blue and green LEDs, and for red and orange LEDs, it's this gallium arsenide based system, indium gallium aluminum phosphide on the substrate gallium arsenide. The LED technology is quite complex. It takes quite a while for processing from the substrate to the packaged LED. It takes quite a while, and if you have the substrate, you use this process epitaxy, where you layer by layer grow the single crystal layers on the substrate. I will write. Yesterday, I have shown in a talk a microscope image of an LED, of a complete LED, you have quite a number of different layers included in that layer sequence. And then you cut the substrate into small chips, about 100,000 LEDs you get out of a 4-inch wafer. And before you cut them, you have to put contacts on it, and the cutting is also not that simple. And then you package them into a package, and you have to contact with this bonding process the chip to the to that package, so that you can bring the electrical current and the voltage to the device. All these different steps might have an influence on the efficiency of this LED. To go a little bit deeper into what happened in the device, I want to show this energy diagram where of an indium gallium aluminum phosphide LED, there are so-called quantum wells inside the active region, and you have a PN junction on the left side, N-type N-doping, on the right side P-type doping. N-type doping, there you have a lot of electrons, and you bring the electrons by applying a voltage to the quantum wells, and there they meet the holes which come from the p-doping region into the active region, and they can recombine. And what we want is this radiative recombination. This is a spontaneous spontaneous emission of photons, but there are competing processes. And this is here also we have in that journal Applied Physics, in that paper here explained and calculated that the main processes are in this type of devices, the radiative recombination, also non-radiative recombinations, which are, that's a competing process. They don't give reasonable photons to us. This runs over traps inside the quantum wells, and another competing process is leakage of carriers. Electrons and also holes can leakage out of the quantum well region, and then they are lost. Yeah, okay. So applications are widely known. I think for Osram, for example, it was very important to have these video walls, because there are millions of LEDs are implemented, and yeah, today you can buy LED beamer, so that's for displays and the display for display applications. An important market is automotive, so for interior lighting and exterior lighting. The headlamps of cars are partly today LEDs, and of course general lighting. I have shown to you this white LED bulb. So indoor lighting and architectural lighting. Yeah, let me come to my last part, to the organic light emitting diodes. Again, this is also a solid state light source, and but it's quite different compared to LEDs. LEDs are high brightness point light sources. They are very small devices, and the organic light emitting diode is one big device. And this device, depending on what substrate you are using, you can also make, you see it here in this photo, you can also, on the right, you can also make it transparent, for example. like a window, and you switch it on, then it illuminates. So, or you can also use flexible substrates, so you can have a bendable lamp. So how can you do that? This type, those organic light emitting diodes, they are solid state devices which are made from amorphous organic materials. So it's not single crystal, but they are amorphous. You can make them by evaporation in the vacuum, or you can also make it, try to do that from a solution. But at the end, they are amorphous, and so you can bring them to any kind of substrate as long as that substrate is planar. But these organic molecules that are in the active region, they are sensitive to oxygen and water. And therefore, you have to encapsulate these organic molecules, and which is an extra step. Yeah, schematic view on the layer sequence is shown in this transparency. It shows an OLED which was deposited on a glass substrate, which has an anode and transparent oxide, ITO, indium tin oxide layer, and on that you can buy that very planar from the display industry, for example, and there you put your thin organic layers. They are very thin, less than 1 micron thickness, and you put a cathode on top of it. You have so that's your metallic contact, and then you have to encapsulate it so that no oxygen and no water comes to the organic layers. And you can apply a voltage around 4 volts. And then you can, if you make everything right, you get white light emission. And the approach is here because you have, these are amorphous layers. You can add red, green, and blue emitting layers on top of each other. So you have this additive RGB approach to get white light. Now the operation principle, again on a carrier for the carriers is shown in this diagram. Again, here you have a doping. You have it's not absolutely required, but for high efficiency, it's required to dope the layers outside of the active region with electrons and with holes. So it's similar to the anorganic LEDs, p-doping and n-doping. And you put from the cathode electrons to the active region. They have to be transported through these doped layers, and the holes go through the p-doped layers to the active region, and there they find and can recombine, and you get photons out of it. So for white light emission, you see here the spectrum of an RGB additive OLED, and they are simply, this is a schematic setup. Blue, green, and red are stacked on each other. Yeah, there are quite a number of technical challenges. I don't want to go too much into these details. Simply, I just want to mention two challenges in that business, in that research. Materials and defects. Let me start with materials, just one transparency. You can buy today more than 2 million organic materials. So these are carbon, hydrogen compounds, different ones. And the challenge is to find the proper materials. 2 million organic materials, and you can even further develop the proper ones. So it's quite some materials research and development to get better organic light emitting diodes. Another problem is if you have those large devices and the substrate has to be planar. If you have one defect, one stuff on one small glass particle or something on that substrate, then it might happen that at this point there is a short. If you run current through the device, and then it comes later to sudden device failures. So the manufacturing requires clean room conditions, and that's quite also expensive. Yeah, this is the OLED I've brought. I have shown to you here in advance. So it's actually 5 years on the market, and today you can buy it for 14 euro via eBay. If you look for reading light, OLED reading light, it's quite a nice device because you can also dim it. There's a dimmer, and you can charge it by USB cable. Okay, other companies are involved in that business. It's LG, a South Korean company here with, you see, flexible OLEDs. So you have so many new designs which are possible. It's quite nice. And yeah, also Philips, I'd like to mention here, that was my starting photograph. They put organic light emitting diodes for the illumination into the Theater an der Elbe. That means that's a theater in Hamburg in Germany. And yeah, that's the lighting, part of the lighting concept of this theater. Yeah, let me briefly summarize. I have shown to you the solid state lighting elements, LEDs and OLEDs. They revolutionize the lighting market. And the LEDs provide many advantages and new features. I think I have to end my talk. So technical challenges I have also addressed, and but typical product data of white LEDs, OLEDs, have been achieved. The luminous efficacy is in the range of, on the product side, of 60 to 80 lumens per watt. In the lab, it was already achieved more than 200 lumen per watts, but for me, it's important at the moment, what is, as a customer, what is on the product side. And yeah, the lifetime is more than 10,000 hours. Yeah, thank you for your attention, and the talk is open for questions.
Thank you very much, Arndt, for the nice presentation. In the meantime, until the questions they will arrive, or I have some questions and some comments, please send me your presentation. This is a kind reminder. So, any questions from the audience? So let me start then. The questions. I will start first with the questions, and then I will move to some points of discussion with you, Arndt. I have the first question is like, you at the beginning you show a diagram with all the light emitting diodes technologies. Am I right? Like starting from the old technology, fluorescence. I mean, if you go over there.
You mean that one?
Yeah, this one. Thank you very much. So when we move to metal halide, are you do you want to say about something about perovskites? Because perovskites, I think, is the new material of light emitting diodes. At least this is the case for lasers. But all the laser devices, they start first of all with applications in light emitting diodes and solar cells, because these are, the devices that it's easier to demonstrate the property as a solar absorber or as a light emitter of any new materials. So I mean, this kind of metal halide over there, do you speak about perovskites or any metal halide material?
No, these are not perovskites.
Okay.
These are that's used for shop illumination. These are quite expensive lamps.
Okay. So I would like to add over there a comment that perovskites, they contain metal halides. They are solution processed. They are direct band gap materials, so they are very appropriate. They are also we can fabricate them using thin films, and also they demonstrate very high mobilities for the holes and for electrons. So this is something very, as you know, and you can reconfirm, very attractive for light emitting devices. They have demonstrated electrically pumped, because this is a challenge, and this was the challenge with OLEDs. At the beginning, they were optically pumped, and then we moved to the electrically pumped, which is something very, very important. So this is.
What efficiency have they demonstrated?
I cannot. I mean, I don't remember by hand, this kind of figure, but I can find it out for you. So I don't want to say something that is not accurate.
Yeah.
I mean, if I would like to say a number that comes from my mind, is like between 12 to 18%, something like this.
Ballpark efficiency.
Yes.
That's quite good, but actually, I'm not familiar with the perovskite up to now.
No, it's a revolution of organic light emitting diodes, but of course, perovskites, because they contain lead, there is a problem with lead. Like, how are you going to recycle them and other stuff? I mean, the environmental impact is it's a challenge right now for this technology, but they have brought a revolution regarding the solar cells. I mean, now perovskites, they demonstrate efficiency as high as the silicon solar cells, and they are solution processed at the same time. But the problem is with lead. There are lead-free devices, but then the efficiency drops a lot.
Yeah.
This is just this is something that I would like to ask you. The other thing that I would like to ask. Excuse me. Go ahead.
No. Yeah. I confess I don't. I'm not very familiar with the perovskite up to now, and as long as they contain lead, it's not possible.
It's a problem. It's a problem.
The market anymore. It's lead-free. It's but maybe it's a new avenue opens up. Yeah.
We hope. So probably, next May that you will visit us again, when, this Erasmus week will happen face to face. Then probably, you should update, this kind of graph with the new things about perovskites. I'm pretty sure that this technology has a lot of potential, not only in light emitting devices or like solar cells, but also recently as X-ray detectors, because for X-ray detectors, the lead, which is a heavy metal, is very important in order to increase the sensitivity and also decrease the stopping length that you need in order to absorb, the high energy photons. Let me move to another question that I have. I would like to ask you about the OLEDs, how much their efficiency. I will come back to the threshold. I have not forgotten this. The efficiency with the bending. I mean, because this is one of the attractions of the OLEDs, that it's not only the glass that you can place them, but also you can place them on plastic that provides them a flexibility. And in Germany, I have to inform if the audience, if you don't know, especially in Erlangen, all the bus stations in Erlangen, they are solar powered by organic solar cells, of course, and illuminated with organic light emitting diodes. That is very nice. And has mentioned, has brought revolution in automobile regarding how monochromatic is the light that you can build, because it's a chemical fabrication. You can control the ingredients, and you can design and you can fabricate the best blue color or the best green color or all this stuff. So, Arndt, can you make us a comment about how the properties of the OLEDs are affected, or if they are affected with the bending angle and also with the bending cycles.
Of flexible OLEDs.
Yeah, yeah.
Okay.
I mean, if you have no idea, just say no idea. I mean, we don't know all the answers, no? It's just from the curiosity, I would like.
Yeah, yeah. I am actually I was working in the OLED field, but Osram stopped the the business last year, and they had some nice results on flexible OLEDs, Osram Opto Semiconductors, and that were gave good hope that this might become also a product, but finally the business was stopped, and so.
Can you make a comment why they have stopped this investment? Because I would like to add you that I think also Philips has stopped to invest in OLEDs. I think that is not a problem of the technology, it's the problem that all this technology has been moved to the Southeast Asia, because Samsung and the other Asian industry and companies, they are still investing a lot in the OLEDs. And I will come to a comment. One of the students has mentioned about how attractive the OLEDs they can be for display technology and stuff like this. I mean, we should inform them that I have here my new iPhone, and all the screens is backlighted by OLEDs, because they can provide this kind. They can make, you mentioned very nice that we can make them as thin as possible, and also they have a very pure colors, like for the emitting. That's why these new smartphones, they have such a nice colors.
Let's say it, put it in that way, the music is playing in Asia.
Exactly.
For at least for the displays. LG Chem, LG is also an OLED display maker. So they have big machines, they put it on large display glasses of a size, the displays on a size 3 meters or 4 meters. And so they have large machines to produce the displays. But displays is a different business compared to lighting. Lighting, the displays, Samsung and LG and Apple, they have today organic light emitting diodes as in their displays, and LG was very engaged, very active in the field of OLED lighting, and also LG has decided that they stop their business in the lighting, in the OLED lighting. Also LG.
Yeah. Another comment that I have to say, like you mentioned, that of course organic light emitting diodes are very sensitive to they are very sensitive to environmental elements like moisture, like any defects. They can affect severely these kind of devices, and we need clean rooms. But I have to add on this that clean rooms we need also for microelectronics, like whatever we're building in microelectronics, light emitting diodes, we build them in clean rooms. Otherwise, all the defects, they can affect severely the device. Nothing happens on room conditions, let's say. But I have to add as an advantage for the OLEDs that we can build them very efficient OLEDs within a glove box. Glove box simulates a clean room, but you don't need these facilities, and it's much easier to sustain this kind of working places like the glove box. This is something that we can do in organic electronics. It's not something that we can do in silicon electronics. Before I move to another question, we have a question from Ioannis Kaliakatsos. Yes, Yannis, the floor is yours. Yannis, if you can hear us, I mean, you can make your comment, but you should speak. Okay, I think that he has problem with. Okay, now he's
Okay.
with us.
Good morning to everybody. Thank you very much, Arnd, for your very interesting talk. I have to make some comments, mainly on OLEDs. I'm teaching a course on display technologies, and in this course I have a small chapter on OLEDs and lighting from LEDs and OLEDs. I have to mention here that the big problem now, up to now, for OLEDs is the short lifetime, especially for blue OLEDs, and thus it's not very convenient to use them for a TV set display. And this is the reason why Samsung has stopped to develop new TV sets using OLEDs, because they have to change this type of TV sets in less than 3 years, and due to the cost, this is not possible. This day one. According to the possibility, the difference in emission, if you have a bend or a stretch or another type of flexible OLED, of course we have to do more investigation about it, because for the moment they don't use, apart from lighting, they not use them in other everyday applications. For example, because we need to encapsulate on a glass, for example, the OLEDs, is not good for the moment to have an OLED display, for example, on a smartphone. Of course, in our days, and just some months ago, Samsung introduced in the market this flipping display, and I don't know, of course, till now how is its behavior, and if you have less emitting light from the OLEDs. It's something that is very interesting, and I would like to go more in this. Very good and very nice was the proposal of Kostas. I don't know if already they do this, to have LEDs from perovskite. If we succeed to have this type of LEDs and overcome the problem with the lead and the problem with waste materials that we use there, I think that this is a good idea to work on this side. And the last question for me, I will ask Arnd if it is possible to send some students there for practical training in their lab in Esslingen. Thank you. This is all I have to say.
Thank you, Yanis. May I comment some of the things that Yanis mentioned?
Okay.
First of all, perovskite LEDs is a reality. Second, I don't, but I'm pretty, they are working now on the electrical pumped perovskite-based LEDs. Optically pumped, they have something.
Okay, about optical.
Let me finish.
It's not for the market.
One by one. I mean, everything starts from optical pump. Optical pump OLED, they started in 1991, and in 2 years they moved to electrically pumped. Everything starts with optically pumped because it's easier to activate the material. Second, now they are working in the electrically pumped, and it's a matter of time. I mean, now they are moving to perovskite lasers, which is something that they demonstrate. It's not like lasing as in the usual case. It's mainly is based on random random lasing, which makes the device more attractive because you don't need cavities. Third comment is like flexibility in organic light emitting diodes is a reality, since the material is not crystalline. It's very efficient to make it flexible. I was looking just for the exact figures, but it's something that is demonstrated as a commercial material.
Yes, for lighting, yes.
No, not only for lighting. LEDs are for lighting. They are using also in medicine, like they have a organic light emitting diodes against photodynamic therapy. This is something commercial.
Yes, I know this very well.
So I answer you that flexibility exists. It's not something on
exists flexibility. I don't know if the emission, the efficiency of flexible organic.
That I was asking. And the other thing, Yanis, that I mean, the point that Yanis has mentioned is very important, to send some students for practical training to Germany. And I have realized that Arndt's laboratory is mainly characterization, but it's something that it will be very useful for our students. Yes. And the students, they follow, and I think that they love Ioannis Kaliakatsos' course in display technologies. So, I mean, they will come, I'm pretty sure that they will come with the background knowledge. And I don't know, Yanis, if you have finished.
Yes, I finished. Yes. Thank you again, Arnd.
And about now the lifetime, yes, this is something else that I mentioned. Yanis mentioned about the lifetime of blue. Blue always was the challenge, even for inorganic ones. Actually, that's why Nakamura in 2000, he has received the Nobel Prize by inventing the gallium nitride. It's a challenge that all the technologies they have, especially about blue, it does not come to my mind right now. I should think a little bit to remind myself what is the main challenge. I think it has to do with the stability of the crystal regarding the inorganic ones and operation in room temperature, because this is another challenge. The first challenge that these devices they have is like to move from optically pumped to electrically pumped, and also operation under room temperature. So I'm not surprised that also for organic light emitting diodes operating in blue is still a challenge. I thought that this has been resolved, but I don't know. Now coming back to Arndt and yesterday's discussion that we have. Okay, I mean, I still believe that organic light emitting diodes as a devices, they have a threshold, and this is like some characteristic of the material. This comes from the energy band gap of the materials. And also today, this is something that I would like to mention yesterday. We have these non-radiative processes and the leakage of electrons. These contribute to losses, and anything that contributes to losses is a threshold. So from any point, I'm very much affected by myself from lasing threshold, but this is something different. So any device, even light emitting diodes, in my opinion, and this is something that we will discuss, or, it's something, that probably we have Yanis here, that Yanis is more expert than me in light emitting diodes. We have the energy band gap of the material that is characteristic of the material, it's the fingerprint of the material, and this energy band gap generates a threshold. Otherwise, the device is not self-powered. I mean, you should externally bias it. You should forward bias it in order to give the energy to the electrons to make the jump, to go from the valence to the conduction band. And then if it's a direct band gap material, to have an efficient photoluminescence device. And secondly, and very clearly, you mentioned Arndt in your presentation, and I like it very much, we have leakages. Leakages that they stop the recombination of the electrons with holes, stop the generation of more photons, and this is a leakage. I mean, it's a loss. This is the same losses we face also in lasers, these non-radiative processes, and also these leakages. So based on this, I'm more convinced to say, probably to my wrong idea, that LEDs also they have a threshold. So your presentation makes my opinion, to believe my opinion stronger than yours. And I don't know, I mean, it's just a discussion. This is a discussion between, we started yesterday with Arndt like a I cannot describe myself as a scientist. It's very hard word to say, but a discussion between colleagues. If they have a threshold. Thank you, Arndt. The floor is yours. Or Yanis. I mean, Yanis. We have Yanis with us.
Okay.
Yeah, I just want to answer to your questions in the following way. First of all, I would more than welcome if students come over to Germany from Hellenic Mediterranean University to work in my lab. That would be great for our partnership between the two universities, Kanya and Esslingen. If you feel that this is an interesting field for you and you get in touch with a new culture, also in Esslingen, there are quite a few Greek. There is quite some Greek population living over there. For example, my car, where I bring my car to my car mechanics, it's a Greek guy, yeah, in Esslingen.
Do they have souvlaki there?
Pardon?
Do they have souvlaki place there?
Yes.
Okay, they will come.
And so you are more than welcome to work in our lab and at our university. Let me just give a comment on the blue emitter.
Arndt, I'm sorry for interruption. We have 3 more minutes with you.
Okay.
Okay, thank you.
Thank you. So the blue emitter, we have very efficient emitters actually around. They were found, and emitter molecules with the proper wavelengths, but the most efficient emitters, they had to, as far as I know, they had a relatively short lifetime, and so there is still a search for even better emitter molecules, and there are emitters which are called their process of emission is there you find phosphorescent and fluorescent emitters, and that's an important topic, even I think still in research to find their good and long-lasting blue emitter. But still, you get you can work with quite reasonable efficiency, especially here for the white additive RGB spectrum of the OLEDs that I've shown to you. It's more important for lighting that it is long-lasting than, for example, for displays. If you want to have a device and a white OLED that lasts for 15,000 hours, then it's the efficiency of the blue one is less important, but the lifetime becomes more important. Yeah.
And the lifetime of this blue LED, it's mainly thermal stability of the material. Why do they have such a short lifetime?
That's I cannot answer that question. I think that's it depends on you here in this view graph. You see what happens. The holes, for example, they have to go all the way through the blue layer, all the holes till they go to the red. So this blue dopant or blue emitter in a matrix has to be stable to holes. And of course also to the electrons, but less because they are at the end of this of the way of the electrons that come from the no, actually no, it's wrong. Actually, it's the other way around. It's the electrons go directly into the blue dopant, and so they have to be stable in that layer sequence. They have to be stable to the electrons. Yeah. Yeah.
So, thank you very much, Arndt, for the discussion. It was really nice, and I think now, if there are no more comments, any questions, we have, I mean, the next lecture starts 1/4 the hour. Now it's 10 past the hour, but I would like to do this Mentimeter again to check out the profile of today's participants. Are there any questions from the audience? Yanis, any other question, comment?
No more question for the moment.
No more. I like this for the moment. Keep the others for the rest.
For tomorrow.
No,
we
no,
have
for
a personal
tomorrow.
communication with Arndt.
All right.
I don't know when Arndt go back to Germany, but if he will stay on also
we can arrange tonight to go somewhere, but I mean, this is something that we can arrange later on.
Yeah, I will fly on Saturday.
Okay. So maybe Kostas arrange something for
Friday
tonight,
or Friday. No, Friday I'm busy. Okay, this is not a part of this now.
Okay.
Thank you very much for presenting my.
Thank you. And then we should move to the next lecture. That is a nice contribution by a neighbor in Greece from Bulgaria, from the Technical University in Sofia. Is the last one before the lunch break. From Professor Maria. I'm sorry, Maria, always I was typing wrong your name. It took me how many drafts of program in order to correct it. I mean, you cannot learn new tricks to an old dog. So Maria, the floor is yours. Thank you very much to be with us. And please send me, you have already sent me your presentation. This comes more to Arndt,
yes.
Reminder. Okay, the floor is yours. And before we move, before we break for lunch break, I should do this Mentimeter. So Maria, the floor is yours.
Thank you very much, Dr. Petridis. Dear colleagues, nice to meet you. I promise I will not take from your time for lunch. I will try to be within the time.
Maria, please, yes. Please use all your time because all of us, we need a diet. So it's not a problem if we miss some time from our lunch. I'm talking about the academics. Including
is the presentation visible to your screen now?
Yeah, yes, it's visible. Thank you.
Okay. Before to start, I would like to thank you, Dr. Petridis, for organizing these events and for your great efforts to keeping us up to date with the current situation and everything about the teaching week. So I'm coming from the Department of Microelectronics. This is Technical University of Sofia, Bulgaria, and I will share with all of you how we teach some of the master students regarding technology-oriented subjects, particularly technology of micro and nano systems. This is the outline of my presentation. I will start with brief introduction of the educational and research activities at the department. Then I will focus only to the master programs at the Department of Microelectronics. Then I will focus to specifically one of both of them, which is microtechnology and nano engineering, because this is a relatively new concept of the specialty in terms of our traditional Bulgarian education. Then I will speak in more details and show details on the subject technology of micro and nano systems. I'm the responsible person of that course. I will mention about the connection between this specialty and the business sector and industry in the field of microelectronics in Bulgaria. And finally, how to fit with the current situation, how we prepare for the distant learning, considering this pandemic situation, how it is possible to organize distant learning for a technology-oriented subject, which is not supposed to be simulation type of education. So, my department is apart from the Faculty of Electronic Engineering and Technology, which is consisting of 4 departments: electronics, power electronics, chemistry, and we are the microelectronics section. Within this microelectronics department, we have 3 basic directions: technology-oriented, computer-aided design, and testing, and quality and reliability testing. Within the scope of the technology-related groups follow the material science and technology processes for micro and nanoelectronic fabrication. So here our recent project and research activities is related to fabrication and study of flexible and glass-based organic and also inorganic light-emitting devices. You will see all the time some photos from our samples. I'm sorry, they are not aesthetically arranged. This is just for our group, for our internal reporting photos. Well, actually, our task is to study materials which are not commercially available, but newly synthesized, and to check whether they have potential to be implemented into real device after the transformation into thin films. Another, our current up-to-date project is related to piezoelectric energy harvesting systems or flexible wearable alternative power supply. Here we study different designs. As you can see here, different patterning of the electrodes, how they could affect the efficiency of conversion of mechanical into electrical energy. Stability against multiple bending cycles. Can we enhance the performance after find a way for nanostructuring of the piezoelectric material? Here you can see nanobranch structure and nanowires alignment structures. It found application in a lot of biomedical devices currently. To power supply sensors for health monitoring systems and so on. And the second subdivision into the technology-oriented subgroups, it is micromodules fabrication, packaging, and surface mounting process. Another person is responsible here. So here we study hybrid micromodules for low frequency and radio frequency devices. A lot of approaches for packaging and for component mounting and bonding. Regarding our educational activity, it is split into 2 master programs: microelectronics and microtechnologies and nanoengineering. Regarding the training in microelectronics, there are 2 semesters. The first one is longer, 15 weeks, and the second one is shorter, 10 weeks. During the second semester, the students have to develop their diploma thesis and to defend it. So the first semester is general subject content for all students, and the second semester they have to choose whether they would like to specialize in power, electronics, biomedical, or micro. I will not go further with the details. Here I put some additional information about the ratio between subjects which are compulsory, which are elective, which are exam or ongoing assessment. I think this is not so important currently. So I will move forward to the microtechnology and nanoengineering master program. In contrast to the previous master program, all subjects, no matter first or second semester, they are not general electronics subject. They're all of them special subjects, tightly related to the micro and nano engineering. So we tried to cover the whole full closed cycle of this process. First, materials, then design, then technological process to involve these materials into this design, and finally testing of the systems. So during the second semester, it is rather flexible actually, because the students have the opportunity to select a range of subjects to form their preferences. If they want to study fundamentals, if they need to study more about reliability, or more on technology, or more on simulation and modeling. That's why specific groups are formed here. And again, the second semester is shorter, and the diploma thesis preparation and defense have to be realized here. This master program is relatively new according to our standards. I mean, the microelectronics education is available from almost 20 years ago, and this specialty ran in 2014 under the program of European Union for operational human resources development. The purpose of this program was to harmonize the curricula in the electronics with the industrial needs. So according to almost 70% of the employers in Bulgaria in the field of electronics and microelectronics, they formulated the need for such a kind of project-oriented specialty. Well, currently the project-oriented means that the ratio between the theory and practice is not well balanced. Currently, in these project-oriented programs, the practical assignments are 3 times more and 3 times more hours devoted to practical preparation rather than theoretical, in contrast to the microelectronics education, which is 50-50 distribution between the lectures and the seminars or laboratory work. Well, what about the technology of micro and nano systems? This is a core course for the training of the students. What is new here? It is that normally at our university and our faculty, each laboratory exercise before was standing alone. For example, you consider certain technological process, but it is not related with the other process in the microfabrication technology. You focus deep into this technological process, you know everything about it, but you cannot apply it in combination, considering all other technological process that will follow or that happened before. Now the building strategy of this course is to implement week after week each technological process to fabricate a real device. It could be really simple microsensor structure, not complete integrated circuits with thousands of transistors implemented inside, but We start with the process of thermal oxidation of silicon wafer and doping of silicon wafer. Here you will see some images from our technological equipment. The students have to work with high temperature furnaces to grow silicon dioxide, which is well known in the microfabrication technology to be conventional dielectric layers. They have to find out how to set the growing condition, the temperature, the oxygen flow, etc., in order to produce specific undergate oxide intended for metal oxide semiconductor transistors or metal organic semiconductor capacitors. So they have concrete assignment to reach specific leakage current within the current standards and specific dielectrical losses against within the current standard. Then they use this silicon dioxide as a protective mask in order to realize simple doping of the silicon wafer with specific impurities, phosphorus or boron, in order to find out how to control the doping concentration and the doping depth. Actually, their final goal is to realize simple transistor structure and to investigate the PN junction, parasitic capacitance, turn-on voltage, etc. The next exercise for them is to use the previously processes during the thermal oxidation and doping process silicon wafer in order to grow the next layer on the top of this wafer. First, we start with single component metal nano coatings produced by thermal evaporation. We have available two basic vacuum deposition installations, and normally we practice aluminum electrodes growth for interconnections of metals and for contact pads growing, and also platinum coatings which we use for micro heaters in our future microsensing structures. Then they should set all parameters related to this thermal evaporation: basic vacuum level, rate of deposition, temperature of evaporation, and they have to keep about the uniformity of the coatings, defectless coatings, specific thickness of the coatings. They have to characterize the sheet resistance and specific resistance and estimate the irregularity of the films by 4-point probe measurement system. Later, they grow metal oxides sputtered by RF reactive sputtering method coatings, which they need for their assignments. According to their preference, they are able to select if they will realize gas sensor or magnetic sensor or temperature, pressure, or other sensor devices. So they need to select specific materials to be sputtered. For example, if they would like piezoelectric sensor, they have to know about the barium, strontium titanite, and potassium niobate, because these are the materials possessing piezoelectric properties. They study about how to establish the oxygen pressure in order to achieve the proper stoichiometry and ratio between the oxidizing component and the basic metal component. They set the proper sputtering pressure with the argon ions. They set suitable plasma pressure, because this is related to the temperature of growing and the rate of growing. The next exercise is photolithographic patterning of the already produced coatings. After they open the vacuum chambers, they realized that the coatings cover the whole substrate, and there is no selectivity of growing regarding the specific dimensions, geometrical patterns, or situation of the components onto the silicon wafer. Then they have to design their own layout. Here I decided to show some example layouts. They have to decide at this stage whether they will use positive or negative technology, and to design their photomask accordingly to be positive or negative. And the level of complexity that we set is at least 2 or 3 minimum photomask layouts, in order to practice the mask alignment process and how to stick different layers into one single device in order to get reliable functionality of this device. So we help them with this photomask design, because it is too expensive to give to them to make it alone. But they drawn at least they drawn their files. Later, what they do alone and practice alone to grow photoresistive layers by spin coating, set appropriate deposition conditions, and find the relation between the deposition conditions, thickness of the photosensitive film, and patterning final resolution according to their photomask pattern and image. Then they practice exposure through the photomask of this photosensitive layer in order to transfer this image from the photomask into the photoresist, and that will use later this photoresistive pattern to transfer further by etching into the functional layer. At this stage, the exposure source parameters are also crucial for the quality of the final resolution. And here I show some layers that they need to align following the marker of alignment in order to stick all these images into the final device. This is the available mask aligner system. It is not a cutting-edge model, but for the training purposes, it is really perfect, because it provides the necessary accuracy of 1 micrometer, which is sufficient for the training purpose. At this stage, they explore a lot of effects and defects into the final coating. I intensively set some inappropriate deposition conditions in order to best comparison of the high quality and low quality of the final results. And here you see some already fabricated samples. Of course, some of them are not perfect because this is their first time touching with this technology so deep, but it is pretty okay, really okay for the training purpose. During the next exercise, they have to use chemical etching in order to transfer their image from the photoresist into the different layers involved. They have to pay attention about selectivity and undercut unwanted effects, which unwanted dissolve the photoresistive mask and could damage the resolution of the final pattern. Again, here they observe microscopically a lot of effects or defects, and they are able to set appropriate solution concentration of the etcher or temperature or time of etching in order to avoid the critical bottleneck effects that could prevent successfully realization of the device. Next exercise is related to thick film technologies because the first 4 exercises are devoted to the thin film technology. However, sometimes when they need better heat dissipation or a specific sensor that should be wear resistance of sliding surface in switching microcontacts, or corrosion resistance sensor in harsh environment, they need to strengthen these thin films to enhance them by selectively increasing their thickness, especially for high powerful modules with greater heat dissipation that the thin films could overburn at this stage. So they perform electrochemical enhancing of the thickness or electroplating if the coatings are metal types. Conventional oxidation and reduction chemical reactions are elaborated to do it. They grow platinum microheaters, nickel Thermolex for thermal sensors and thermal transducers, and gold contact pads for later for their chip mounting. For the layers which are not electroconductive, this electroplating is not applicable. So they use screen printing technology, applying different dielectric, electroluminescent, piezoelectric or other type of pastes or ink. And this is the available screen printer. They find out how to prepare alone the screen topology because all the screens are customized according to their assignment, according to what they select to realize. After that, if one of them has a specific membrane configuration, he or she need to practice anisotropic deep silicon etching, or more popular as a bulk micromachining. For that purpose, at the beginning of the course, they have to select proper silicon wafer with specific crystallographic orientation, allowing to perform later at this further stage this deep silicon etching, because as most probably you know, this process cannot be reviewed in any kind of crystallographic orientation. Most often they select to fabricate micromembrane from silicon for most capacitor structure with movable electrode for pressure sensing. And here are some examples of the fabricated membranes, successfully and not so successfully cut from the wafer. But here in this cavity, there is a free space for motion of this flexible membrane if the external pressure is applied. And if it is stick with epoxy resin to a combination of fixed electrode with bottom aluminum capacitor electrode and a suitable dielectric film, then this pressure supplied into the membrane will cause deflection or changing in the distance between the movable and flexed electrodes, and the capacity changing in reverse direction according to the distance variability. On the next exercise, they have two preliminary tests before bonding, packaging, and encapsulation. They are microstructures, whether they function or they need to additionally fix some errors or calibrate some films by additional settings. When they find out, they go further with the bonding, packaging, and component placement. Here we have a bonding machine for wire bonding of goat wires. And then we use plastic packages, specific epoxy resin for compound for decrease the air permittivity and humidity permittivity, and we use component placer alignment machine with precise chip positioning and dispensing system that can solder precisely the future integrated circuits into the standard corpus, into the standard package, and precisely align onto contact paths. Of course, the sensor device could not be really functionizing if no suitable signal processing circuit is not realized. That's why the next technological step for the students is to fabricate alone the printed circuit board in the lab. They use Textolite copper coated pieces. They cut according to their design, according to the specific circuit. They laminate with photoresist. Again, they alone design in Proteus the layout for the traces, conductive traces, and the place for through-hole mounting of the components. They perform, again, photolithographic steps, conventional exposure, developing of the patterning, after that etching of the copper unprotected with the photoresist, after that stripping of the unnecessary photoresist, drilling of the holes for the through hole mounting, and soldering of the discrete components. So this is their signal processing circuit, and at the input they connect their microelectronic sensor. Of course, they have to think about how to arrange specific testing setup in order to check the functionality of their microsensor and functionality of their PCB power processing circuit. This required a lot of preliminary preparation before they come into the lab. That's why before the laboratory exercise, they have an entrance test, including task for related to the solution that we discuss in the class that they need to pass through during the laboratory exercise. During the laboratory exercise, the training is combined mode. They have to realize some individual tasks and they need to work as well in a teamwork. I mean, they need to study about the general effects and defects related to the specific technological process, and then individually they have to apply them this process to realize their own individual design. After the laboratory exercise, they have to prepare the report, the description on their individual and teamwork task. And they have additional homework to study about the technical specification of materials and equipment needed for certain process. In this way, they also practice English language for special purpose, which is technical English language, because it was found that this is a very big problem during the education of our students. They know very well English, but for talk with the general public, but they could not practice very well technical English language. And this is crucial when they go further in the companies and work with in international team with managements who are not Bulgarian people. And of course, they have to prepare course project optionally, similar to the topics of the laboratory experiments, but with additional calculations, simulation, additional drawings related to the micro device construction and performance. So here I'll briefly mention about the industry in Bulgaria, which is oriented to the microelectronics. And these companies are the main consumers of the educated students coming out from our specialty. Smartcom, which devote to micro and nanoelectronic device design. AMG Technology is fabricating MEMS and NEMS structures. Sensata Technologies is for automotive sensors fabrication, design and testing. Melexis is the same branch. Centillion is more general electronics, but again, biomedical, sensing, and so on. Optoelectron. And we have here technology and innovation, Sofia Tech Park, which is the bridge between the research innovation and the industry needs. Finally, the COVID-19 challenge. The first trial during this spring semester was really not effective and really not very successful, because this technology-oriented subject is not supposed to be transformed into simulations. And the students had to watch some videos, some animations, but it was really not satisfied. We have developed at the department homemade platform for electronic management. It is fully in line with the commercial system standards with additional functionalities, but I will not go deep insight into these functionalities. If someone is interested about these systems, you can always write me an email and discuss additional new features of this system. But we decided to apply for funding and develop a project proposal for virtual reality and augmented reality training by using C programming and Unity 3D computer graphics motion capture video devices for video games development to realize in future, I hope, if the funding could be get, to develop a virtual room, virtual laboratory where each student could not just watch a video and animation, but interact in live and decide how to set the process. And it is like, yes, it is like real interactivity. We will see if this would be effective, if this would be more engaging about the students. For now, it is just an idea. Hopefully, we will be able to develop during these winter months and start the next spring semester, if there is pandemic situation, with this more effective approach. Thank you for your attention. If you have any questions, you are welcome to ask.
Thank you, Maria. I would like to inform you that send me an email and we will participate in this project. We are very much interested in any new approaches regarding teaching. So please send me an email and we will support you as a department and as a university as much as possible. So it's up to you to send me more information.
Thank you.
Coming to the audience now. Do we have any questions? Any questions from the audience? So, I mean, first of all, I would like to thank Arndt that he has already sent me, the presentation. And also, Maria, I would like to ask you, very impressive. I would like to inform the audience that this is the best university, the most prestigious university in Bulgaria. So it's also, this is another honor that we have as a university to have yesterday one of the rectors, and today, Professor Alexandrova, if I pronounce it well, from the Electronic Engineering Department. You are not professor, you will tell me.
Yes,
because I'm saying the same. So
yeah.
Dr. Alexandrova, thank you very much for this clarification. I would like to ask you, are there any tuition fees for the students to follow your undergraduate or postgraduate programs? Do you have any tuition fees?
I'm sorry, I couldn't.
Do you have any tuition fees for a foreigner student to follow your programs, your undergraduate or your postgraduate program? So if a student would like to register to follow one of your postgraduate degrees, are there any fees? Tuition fees?
I have to check. About the case. About the Bulgarian students, there is a single fee at the beginning. No, it is not annual fee. For the students abroad, the fee is different, but I don't know exactly the amount of the fee.
And
in any case, it is affordable fee. It is not something.
And this is my point. I would like to mention to the students that Bulgaria is especially Technical University of Sofia, that we have a bilateral agreement. There is an ideal destination for the Greek students, since the country, the cost of living, it's as in Greece, or probably even lower. So they offer high quality program. So it's an attractive destination, an alternative to all the other destinations that usually they follow. And Maria, I have another question.
Yes.
If a master student of us would like to spend a semester in a similar master degree in Technical University of Sofia, is this possible? I mean, he should pay for the semester visit a tuition fee, or it's free?
I think it is according to the agreement between the concrete universities, and I think if it is under Erasmus program, the Erasmus program cover this fee.
No, the Erasmus program, I think that covers the subsistence and the travel cost, but I don't know if they cover fees. I think that they don't cover, but I have to check.
Yes, I also have to check, because during the last 4 or 5 years, we hadn't students specifically at our departments, which are here according to Erasmus program. So I don't know about the current state of the art, current situation about this regulation. But 5 years ago, it was related and it depended on the specific agreement between the universities. And I think there is an option for additional agreement out of the Erasmus program. I mean, bilateral cooperations out of Erasmus programs.
So Yanis would like to mention something.
We have to check whether, for example, your university is in such a kind of network with our university. And
yes, Ioannis Kaliakatsos, the floor is yours.
Yes. Thank you very much for your presentation, Maria. And I'm very happy that every year we have many participants for Technical University of Sofia. in our Erasmus weeks. Unfortunately, this year we have only online presentations. But I had to mention here just because Erasmus program does not permit to ask for fees if in your bilateral you have include some specific programs. For example, if we ask to have a bilateral agreement and include MSc students, then the MSc students during their Erasmus period in Bulgaria or your students in Greece, they have not to pay fees. But sometimes there are universities that don't agree to have Erasmus students in specific courses. I know, for example, the British universities, they don't like to have bilateral agreements in some courses because they have high fees and they don't like to have extra students. But in general, for a 6-month period, 6 months, it's for a semester. If we have a 2 years course in, let's say, in a master's degree or in 1 year and a half, usually the non-British universities, they don't ask for tuition fees. It's a rule of Erasmus, and the most of the universities agree on it. Thank you very much for my comment.
Thank you, Ioannis.
Yes.
Thank you very much. Probably we should, I don't know why this happened. Probably you should mute your microphone now. Thank you very much. This is a very useful comment. I should check, the bilateral agreement that we have with Technical University of Sofia, and then I will speak with the international coordinator.
If I send this, if I personally send this to Sofia, I have included any course.
Any course, but have you included also postgraduate courses?
Yes. One, first, second, and third degree.
So Maria, I'm afraid that you have signed this bilateral agreement. So if we have students, they will come with no pay, with no fees. But of course, I mean, if they will come, we will be very happy. I mean, this idea, we have also with us the director of our master degree that is very much related with your courses, Professor Variabasis, and probably, I mean, to give another option to our master degree that they can go to spend a semester or to implement their practical traineeship to a very, very good university. Probably this is another attraction that we can render our master degree in collaboration with Technical University of Sofia. I don't know if Yanis would like to add something, but if he agrees, I can see that he agrees. I like his background because it's similar with mine from the electronic engineering department. Thank you, Yanis. So Maria, thank you very much. And before we finish, are there any questions? I'm like the steward in the Aegean aircraft. Any coffee, please, before COVID-19. Now they don't serve coffee for security. So before we move for the lunch, we have a couple of minutes, and I will call you. I will share my screen in order to do the Mentimeter. It's something that I would like to register the profile of the participants today. I mean, why I'm doing this? Because this provides me information about the profile, but also about the participation and things that probably we can change later on. So please join. It will take just 5 minutes with me, and before the lunch break, I'm working for you. I mean, you don't need to eat lunch. You are going to be slimmer and more athletic. Let me first to find it. So this is the. You should go to Menti.com and use the code 83808081. So it's up there. We are 63. Now I think that some students, they were in hurry to go for lunch. So if we got, per question, if I get, around 40, 45 responses, it will be very indicative of the group. If. Wow, we have our undergraduate students, you know, they're still with us. Very good. We can hear Yanis that he tries to memorize the code 83-80-801.
I'm very bad in the thinking. I remember.
I'm the same. '28, come on, guys, let's push it a little bit. Wow, we have a postgraduate student. This is, you know, the first day that we have a postgraduate student with us. Thank you. I don't know who is here. I don't want, you know, to know, but thank you. 30. Come on, 10 more, 10 more. We can make it. Otherwise, there are so many just screens. Oh, yeah. Someone should call George Liodakis that his internet connection is very poor, so that's why he cannot join us. Ioannis Gaitanakis. Wow. Ioannis Gaitanakis is the next basketball player, I think. No? Oh, Galanakis. Sorry, I'm sorry. We had the postgraduates yesterday. All right. They did not vote yesterday. Okay, I think that I should push it a little bit myself, otherwise we're going to miss the lunch. Name your institution. So, another conclusion that I have extracted during the organization of similar things is like probably you have registered, for example, 200 people, 100 of them they will attend and 50 of them they will be interactive or follow the instructions. So we have a dropped in each number by 50%. $34, I think I will stay with this number. So how do you learn about HMU? Very good. You're ready, eh?
Yeah.
Okay, let's move. Why do you participate in the Erasmus Week? We have some answers, you know, other. I mean, can I have the opinion of the person that has replied other? What is the other reason? From curiosity. You can write privately to me to the chat or publicly, you know, to everyone. I'm very curious to see what is the other reason, honestly.
Building a partnership, it's another, let's say, expression for the synergies.
Okay, thank you. Thank you very much. I think it was Mohammed.
Mohammed, yeah.
Yeah, from Egypt, no?
From Egypt, Mansoura University, yeah.
Thank you, Mohammed, to be with us all the days.
Thank you, thank you.
So, in which session are you interested in? Thank you. I'm going to wait. I'm going to count to 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm moving to the next one. Do you plan to attend the whole International Week? Yes, partially. Wow, no answer until now. What did happen? Strange, no?
Yeah, I answered.
Probably slow. Ah, okay. Take some time.
Oh, okay.
Thank you, Panagiotis Zachariou. Probably the software was stuck. Thank you. Okay, let's move to the other one. What time do you think such an event should start? Because sometimes this is Greek time -1. I would like to check, you know, if you are early birds or late birds. So 1 hour later, 10 o'clock CET means that we should start 11. The other one, what do you mean? At around 12 o'clock in the night? What time? So probably we should start all the such events a little bit later. Probably for the online events, because we had also participants from Portugal. This is -2 hours, or in UK it's -2. Probably it's harder. All right. Okay. Okay. Thank you, Ioannis. Ioannis is early bird. He suggests to us 8 o'clock CET, 9 o'clock Greek time. Okay, so I will stop share. Thank you very much for your participation for the first session. Don't forget, after lunch break, don't eat too much. We have an hour, almost an hour. We will come back 2:15 with two more contributions. One is like the best ICT tools for education from Jonathan from UK, from Staffordshire University. And then I have another colleague that he belongs to 7th International Week, the Special Forces. They are next to me, 3 of them. They were very dare to come to the same room with me, despite of COVID-19 and all the pandemic. Professor Jürgen Koch from Essling, and he will teach our students and ourselves. I don't know anything about programming. The last time that I did programming, Nikos Petrakis, was Fortran 77, and it was the last course that I passed to take my degree as a physicist. So he's going to teach us about Python.
Python, yes.
Thank you, thank you. So come back 2:15. Let's do it 2:30 in order to provide more time to the people, since I have spent 10 more minutes. So let's come back at 2:30. All right, local time, which means 13:30 CET. So this means in an hour and 20 minutes. So see you after lunch. So welcome back. I think that we are ready now. We are 1 minute before the startup of the second part of today's session. We have 2 more talks to introduce. One from Jonathan Westlake from Staffordshire University about the ICT, the best tools for ICT, if I remember well. Please correct me, Jonathan. And the other one is a contribution from Essling University, from our friend Jürgen. He's opposite to me. He's preparing his monitors and his stuff. He's going to show to us how to make simulations using Python. The recording has started. Let me check okay, yes, Jonathan, you have all the authorization to share your screen and share with us your enthusiasm, your nice presentations, and the topic.
Okay. Let's maximize that. Hopefully everybody can see my screen. Give me a thumbs up, Costas, if you can see the screen. Yes, that's great. Welcome, everybody. Nice to see you again. So I've got 16 slides. Whether I get all through all 16 remains to be seen. The title, as Costas mentioned, is Best ICT Tools, so Information and Communication Technology Tools. So I'm going to go through really a range of tools that I use day to day in my various roles. I'm a man of many hats, so I've got tools for all sorts of things. And I'll give it a little bit of context. And hopefully, of course, some of the links I'll show you and some of the things I use are global. And of course, you've got access to and you may be using already. And of course, some may be a little bit UK defined, and you may have the equivalent in your home country. But as always, at the end slide, I've got my email and details. You can get in touch with me. Obviously, there'll be a little bit of Q&A as well. Do get in touch if there's something that's not clear or something you want to follow up on. That's the beauty of this type of week, and also sharing what we all use. Okay, so I for Staffs University, but those who didn't join us on Monday, I'm an entrepreneur in residence, rather fancy title. I'm currently involved in a number of government-led projects to help small businesses. So I'm currently, my head's full of project work, endless conversations, and supporting local businesses in Staffordshire, who are of course going through a rather difficult time. So that's one of the things I want to actually sort of, sort of give you a little bit more description about the things we're using for that particular type of project, because of course everything's online, so everything we're doing is really using a variety of tools. So that's like a case study I can sort of describe to you shortly. The other tools really relate to stuff I do in my other roles. I'm a director of what we call, well, the same sort of expression as you'd use in your home countries, a makerspace. So I've got a small firm where we have a space which allows people to come in and use the equipment we've got there, whether it be laptops for doing some Python programming, whether it be screen printing, whether it be laser cutting, even sewing machines. We've got a makerspace, and we've been involved in a number of Erasmus projects over the last few years, one in Poland, where we helped set up a makerspace over there. They used our template, shall we say, as a way of sort of getting their makerspace up and set up and running. And I've seen various makerspaces on my travels in Europe. I saw one in Brussels not so long ago. So the format of the session, and I will pause. I tend to talk quite quickly, so I will slow down. And do interrupt me if there's something else. You can put it in the chat, or you could just sort of put your hand up and sort of just ask your question as it's immediate. But I think most of the questions will be at the end. So the perspective I want to get across is really what are ICT skills, and at near the end of my slides, you'll find I've got like a little kit list, as I call it. So for the students joining us, those people just about to embark on their career, or thinking of setting up their own firm, like myself, really, I'm an entrepreneur. I've got my own firm and I help other firms, but I've also got a foot in the academic side as well. So I'm a hybrid of both, really. So the business side for me is just as important as the academic and research side. They go hand in hand. So the kit list may be of use to you, because you'll be able to look through that and think, oh, I hadn't thought of that. I haven't got that. And this kit list can be anything from social media. I'm a big social media user. I know there's a debate about social media, and of course there's a debate about these things. I live my life. Let me just get it on the screen. There we are. I live my life on one of these, my smartphone, nice latest Samsung one. And of course this is both a blessing, but also a curse. It's meant a whole revolution in the way we work. Gone are the days of a 9 till 5 existence. It's really now access at any point, and I have an understanding family who know that I can be contacted at any point, and in a sense I'm always online. I'm always there to support. Okay, I don't mean 3 in the morning when I'm hopefully asleep, but I mean evenings, weekends. I'm really continually available, because I have to be, because that's the way we work now. So I'll be looking at open source tools. Now, open source have always been, I've been in information technology, computing many, many years. I go really back to the early mainframes, then mini computers, the early PCs, the early laptops. I've got kit sort of stored away also, which I don't use anymore. And of course, I'm always upgrading. We've seen a revolution in terms of what we use. And what we're seeing at the moment is a revolution in how we use it. I'm sure you saw in the news only of last week, Microsoft announced that you could work at home on a permanent basis. And other IT big companies are following suit. This idea that you go to their campus or work in an office is now gone. And we're going that way with the university a little bit as well, where what used to be like an exception, you're allowed to work at home, as long as you're getting on with something, question of trust. But now it's just become, well, that's where you are, and we can connect with you and you get on with your work from there. That leads to all sorts of challenges, of course. That's not a completely smooth transitional solution, but it's happening, and companies are recognizing that, regardless of COVID. Really, my forecast would be, and I think the majority of you would agree with me, that's probably going to be how it is going forward. Whenever COVID actually gets resolved, or ever gets resolved, or gets mitigated, shall we say, home working's become part and parcel of what we do. So the open source tools have always been of interest to me, partly because, of course, they're free, tend to be anyway. So the open source tools are have always been a magnet to me. So I go back to the early open source tools for things like programming, editing tools, collegiate software, and of course there's very famous sort of versions of this where people contribute to the software library. It's not really owned by any particular body. It's continually moving sort of development. There's plenty of server side. What I mean by that is server side software, but also integrated development environments. I think my colleague doing the following session will show you one of those with Python. I use Python a lot. Love it. That's really like a worldwide club, as I'm sure my colleague will describe when Jürgen speaks. It's like being part of some sort of Python community. You don't just do programming, you're part of a big club and you exchange ideas. That's always been really the open source side, aspect, and that's always something that we've looked at. To some extent, the big companies have gone down that route as well. Of course, really Office now is open source. You can use Office in the cloud. So what we've seen over the last 10 years, of course, is the growth of cloud computing, and the firms making their money in different ways. Whereas, when I think back to my earlier years, it was all about licenses, and you paid for the license and you renewed the license. Now we've got really things which are available, and you've got various levels of what you want to subscribe to. You can start with a basic level, and I'll show you a basic level piece of software shortly from a Danish company. I've got various e-commerce sites or websites, and I'll show you, well, I'll indicate where it is. You can have a look at it in your own time. We haven't got time to really just go through the whole website, but I sell products as well. So open source software, of course, appeals to me. As I've already hinted at, the digital world is very interesting. Now, what do I mean by the digital world we operate in and the impact of COVID-19? Well, I suppose when we reflect on COVID-19 in years to come, we may see that it's been a catalyst for change in a positive sense. I know it's very easy at the moment to look in a negative way. In the UK at the moment, it's terrible. We're having a really rough time with the COVID-19 situation, how to deal with it, how to balance the economy, jobs with health. It's almost like we are in a war, really, where there's casualties, and how many casualties can you accept, that kind of scenario. The digital world, of course, is always moving. We've seen that in newspapers, moving from paper to digital means, and we've seen it with the collaborative software that we're all using now, as we're using today with Zoom. So the impact of COVID-19, really, I think that's of interest and something to reflect back on. The best way I can probably describe that would be, look at how your own processes in your own institutions and companies and individually have changed over the last year, 2 years really. And I'll give you an example. For one of my other hats, I'm an external examiner, partly because I've been on the planet a long time, seen a lot of things. So I'm an external examiner for a number of universities in the UK. And of course, traditionally what they do is send me assessments, which are just about to go out to the students. And what I also do, of course, is moderate or externally review the results at a later stage. I suppose not too long ago, that would all arrive either by paper or via email. Now, of course, everything arrives by SharePoint. So I've got a folder at the host university, and they put stuff in there for me to review. I update it, put my documents in there. So we've got a shared environment. We collaborate, and that's how we work. And that's become the norm. And it's become increasingly how we refine the norm and make the best of it. So this idea of a really collaborative space where we can put documents, videos, etc. Of course, whether it be SharePoint, Zoom, Google Drive, which I use, and you'll see that in my kit list, OneDrive, for example. There's all sorts of others as well about how we transfer stuff around. So the impact of COVID-19, of course, is changing really how we operate. And that's something that you can all reflect on, and I continually reflect on, about how the process can change, how we can best get the best use out of the technology. It's no point just using the technology and then not really looking at how it fits into the flow of what we need to do. Otherwise, all we're doing is automating something and creating probably more work. Now, that's a moot point, because at the moment I find I'm busier than I ever have been. I really didn't forecast that. So I'm really like a full-time, part-time on various jobs, partly because of technology, because of course it creates an expectation of speed that you can turn around things very, very quickly. And also it sort of, in a sense, creates an expectation that really, I've just sent you that now. Can you have a look at it? And of course, you've got to schedule things. So how we plan for using these digital tools, these ICT tools, of course, is very much of interest to us all. So my reflections are really, as I say, working in a variety of arenas, and how to keep in touch, how to keep in touch with people on the move. I'm a big WhatsApp user, for example. That's also a blessing and a curse. Some groups I just don't get involved with because there's just too much messaging. It's for those of you who do programming, it'd be rather, and I'm sure some of the students joining us will recognize this. If I go back to my early years when I was programming, we used to get so much, don't laugh, we used to get so much machine time. So you'd really develop your program very well, and then you'd load it in a sense, and then you'd get the results. What we've now got with, of course, the more machine power, an abundance of memory, etc. There's a temptation to do the little change, and then you sort of try and compile it or run it, and then you get a result straight away. And it becomes a little bit inefficient if you don't watch it. You're doing sort of little micro movements rather than sort of looking at something and saying, right, I've checked quite a lot of stuff now, let's see where we are with it. So the same can apply really sort of to keeping in touch. You've really got to just look at really sort of how you actually manage the tool. Otherwise it will manage you. You will be sort of forever at its beckoning, which of course is going back to these. This becomes almost like some sort of organized thing. You think, right, am I in charge of this smartphone, or is it in charge of me? I mentioned about being an entrepreneur as well. So some of my tools, which I'll mention, I will keep to time, are really about how to promote yourself as well if you want to find work. Now, some of you, I'm probably talking to the students who are joining us, have ambitions to become, have your own business, work on your own. Some of you work for organizations. It's good to do a combination of all of those things, of course. But really, how to find work, of course, is quite an interesting question at the moment, given the economy that we're faced with. Some people have never been busier. I give you that as an example of myself. And some people, of course, have got no income or jobs at all at the moment. Depends on which sector you're in and what you do and where you're going with it and what age you are as well, as to some extent. Context, further context. Top point there, I don't like to spend any money. So if I can get something that's open source, is robust enough, then you have to accept a little bit of change with the product if it's not a fully licensed packaged shrink wrap product. If it is a piece of collegiate software, things will go wrong. For example, those who do programming, I never trust anything that's put up on the forum. I do get students saying to me, this bit of code's not working. And I say, well, is this your code? Oh, I got this bit from somewhere else. And I've tried to put it into my bit of code and it doesn't work. Well, usually my answer is, well, it probably won't. It's not really trustworthy. It's probably just an idea of what you could do to resolve the problem, come up with a solution. it's not really to be taken verbatim as being, oh, that's exactly going to work. So really collegiate software, open source software, of course, there's an element of risk involved. But what we've seen with the growth of cloud computing, of course, is really in freely accessible platforms that really that's become less of an issue. Whereas I think of back sort of 10, 15 years, there was an element of, well, we don't want to do that from a firm point of view. We better stick with the stuff we know, even though perhaps it's not what we want to do. And we could save a lot of money by going to something else. So you'll find a lot of people still, well, firms in the UK still use Office when, of course, they could use OpenOffice. And of course, Microsoft have gone down that route where you could argue, well, in a sense, it's like OpenOffice. Okay. So the gold dust is, as I put there, is using the cloud and finding a bit like apps, really. I know there's an app for everything, it seems, at the moment. Some apps are very useful. Some apps are really just overhead and not worth getting involved with. So how you choose your apps, I'm sure you're all app friendly and use various apps on your phone. And for example, I've got a Microsoft Teams app. I've got Zoom on my phone, etc. I'm talking to you from my desktop today, my laptop, I should say. Other things which are going on, the context of these tools, data. Data's become the big thing. Data gathering, data mining, data legislation, data restriction, data confidentiality. Yeah, we could go on. We live in a world full of data, and trying to actually make sense of that data. And of course, COVID is a very good example of that, really, trying to make sense of what's going on. But of course, from a more day-to-day business point of view, this is exactly what we're after. We want to know about what's the impact on our business or as an individual, what data can I gather? And that can be from all sorts of mediums, whether it be social media, databases, surveys, etc., etc. I'll hint at some tools that I use for that. And those are, of course, to measure the impact of effort. We're always looking, aren't we, as individuals and also as businesses, about how we can actually improve our productivity. And everybody nods at that and think, yeah, of course, yeah. I don't want to be inefficient. But of course, it's continual, that reflection on how we actually make sure we're competent in certain things and we make sure we can actually use it effectively. And that's really a learning curve. Look at Zoom and Microsoft Teams. There are learning curves in everything that we use. And oh, right, I didn't know it did that. For example, on Microsoft Teams yesterday, we had a presentation from one company and they couldn't maximize the slides. And of course, we told them, well, you need to run the slide from the Microsoft Teams environment. What you're doing is running from your own machine, and the viewer will not actually let you sort of maximize. Oh, didn't know that. Where's that in the manual? I say, well, it's not really. I'm not sure where that would be, but I just know from experience that those are the things to watch out for. So experience becomes, of course, and as I say, habits and behavior, things that we learn on the move, shall we say, and reflection on really what we're trying to actually achieve. So a world of data. So it's my first example, really, gathering knowledge of the world. So ICT tools for that. Terminology, which I won't go through every point here, but terminology that I'm sure you're all familiar with, particularly those of you who are in engineering, electronics, of course, is data sets. And of course, the world is awash with data sets, whether it be a data set about electronic products, whether it be a data set about trees and where they are in a particular county. These are the things. And typically, these data sets are available as open source. So if I think of my local borough council, we have borough councils in the UK and we have county councils. Borough councils tend to put up things like environmental data sets, things about your own patch, shall we say. County councils and the government will put up things like road statistics, deaths on roads. So that transport companies will put up details of their timetables. What we've seen is the open data movement about publishing data out there in the public arena, and then you can actually access that data, whether it be in an Excel spreadsheet, whether it be in a comma separated file, whether it be in some other format. You can go and get that data, and then you can use it as your baseline to draw through. And of course, data tends to be available in all sorts of weird ways. So, for example, we talk about GDPR and confidentiality of information. Well, it's interesting sometimes. If you go on, this is obviously a UK site, the company's house, of course, companies register. well, by clicking on that and searching for directors, you get all sorts of information about the individual. So, for example, you can, I'm not going to do it now, but you can find more about me, you can find my age, you can find where I live, all sorts of stuff which is out there in the public domain, because of course, as a director, that's what you actually have to publish. You have to say, well, this is who this person is, and there's a track history, and it's got, you know, history about their financial arrangements and the companies that got involved in. So in my case, you'll find I've got sort of 2 directorships there, and it's out there really. It's a question of really this idea that you could, in a sense, limit your data out there and on the World Wide Web is really probably a myth, because of course you never really get rid of every little link. It's you exist in all sorts of places, in pictures, text, etc., etc. So the challenge is to try and use the tools which are available to us. And so what I like to impart to you, and the way I would encourage you to look at information communication technology tools, is to look at it from a DIY point of view. And that can be obviously as an individual, but also with you working inside a firm, whether it be a small firm or a large firm or an institution like a university, or a student who's studying a course. So my strategy, I know it's a little bit small, this print here, but if I just move my arrow to each one. So the strategy would be, think about really, you know, the tools you wish to engage with. Now, sometimes the tools, of course, are given to you because that's what the institution or the company will use, and say, well, that's what you've got to use, and that's our policy as such. So it's really a combination of things that you like to use, and also, you know, it's the things which are a part of your company profile. So, for example, WhatsApp, I use WhatsApp. I use that for work with the university, but it's not really something which, of course, is a university thing. It's something that I just use with colleagues. It's nice and instant. We have little groups and we can exchange information more quickly than we can do via email or via other mechanisms, or even a phone call. We just sort of keep up to date that way. So that's an example. So part of the DIY approach would be a LinkedIn profile. I'm a big sort of, you know, user of this. I think it's a wonderful tool. Various reasons why I've got a LinkedIn profile, and I put my LinkedIn profile at the end on the last slide, so you're welcome to look at that when we get to it. But LinkedIn, of course, useful for recruitment, for finding jobs, and also useful for finding out about other people. So I often, if I don't know somebody, I go and look for their LinkedIn profile. I might look for their Facebook profile, but LinkedIn is a bit more professional. It's more about the work environment I would offer, rather than being something which is more like a social media tool. So LinkedIn, I think, is almost becoming like a de facto presence. It's useful to have a LinkedIn presence and update it within reason. You know, I haven't got essays on there about boring stuff about me. I've just got really, you know, who I am, what I do, a picture of me, where can you find me, you can get in touch with me, those kind of things. Some people go a little bit further than that. They have all sorts of history and continually work at it. I think it's a question of finding a balance, really. So my LinkedIn profile is something where people can, you know, drop onto it and say, do you know what I say, who's this guy? We're just about to have some involvement with him, and it's got a little bit more about me. Other tools which are available for your DIY, well, in LinkedIn you can do things like campaign management. So if you are a small firm or even a larger firm, you can run some sort of campaign from there, i.e. about an event or something you actually try to sell, or it could be exchanging knowledge. Now those of us who are researchers, of course, we tend to use ResearchGate, don't we? So I haven't put that in the slides today, but I've got a ResearchGate profile, and not a massive researcher, but I've got some papers up there, and of course people see those and they publish them. A bit like, of course, these Erasmus weeks. You know, there's in the past, and of course this week, the presentations and well, not the presentations, the papers from the symposium will be put up into something which is navigable and can be found for research purposes. Other things which are useful in my DIY sort of exchange with you. MailChimp, I use MailChimp a lot. It's useful for gathering if you want to do an email shot, a mail shot. MailChimp, dead easy to use, freely available. Okay, so you can actually sort of do a mail shot which is of sufficient numbers. And so if you haven't used MailChimp before, have a look at that and get an account and have a little play with it. Okay? But I'll leave that to do that in your own time. Twitter. Well, I've got a bit more about Twitter in a few slides further on. I use Twitter a lot. I tweet. I know it's not everybody's cup of tea. For example, Melanie, my wife, won't touch it. She said, why would anybody want to know about that? But in all fairness, I think she's missed the point. I tend to tweet things which are useful. I don't tweet about what I'm having for tea, or I tweet about what I'm doing or where I've got to. A bit like checking in with Facebook. I find that's quite useful, though. People can actually see where you've got to. And within reason, you don't need to check in for everything, but you can actually, it's trackable. You can say, oh, that's interesting. He's just tweeted about that conference, or he's tweeting about something he's going to, or he's tweeted with a picture. So, obviously graphical, some sort of media is actually useful for tweeting as well. So I tend to use that as one of my big social media marketing and promotion and knowledge sharing mechanisms. For example, for the small business project I mentioned, we tweet about our weekly sessions. We tweet about recruitment to get onto the program. We tweet how it's going, and we get response from that. We get people sort of commenting about really how they found it. And I think people are interested in that, aren't they? We know that from other, if I give it another analogy, if you think of hotels and staying in hotels, things like TripAdvisor, whatever anybody says, people do tend to look at those. When you're just about to book a holiday, you go and look at the comments, don't you? Sometimes the comments are a little bit biased, sometimes they're very variable, but generally you just look through and think, well, let's see what people are saying about this. They've been on the ground, they've been there. So people's opinions, sentiment is actually useful. And it's very useful from a data point of view, as I'll point out in a while. Getting used to Twitter, of course, is something that needs a little bit of thought. So I'll talk about really what I call a house style. So designing your tweets. I know it sounds a little bit, designing my tweet. Why would I want to design a tweet? Well, if you think about it, it's actually good to do a structured tweet rather than just make it up on the spot. I know it's meant to be very instant, and we know from certain politicians, particularly one in the United States, I think he tends to tweet from the hip, or he's got somebody who actually does it for him. But sometimes his tweets, you know who I mean, get into a little bit of trouble because, of course, he tends to say something which is either inflammatory or maybe just misconstrued. But you do need to think about what you're saying. So you can follow people and they can follow you and all this kind of thing. It's useful from a business point of view, and also to collaborate and connect out with people. Hashtags, of course, misunderstood a little bit, but a hashtag obviously is a collection. So it's useful to actually use hashtags in your tweets. So it gets sort of, in a sense, well, I'm not suggesting that any of my tweets get trended, which of course is really sort of, there's a lot of people looking at it. But it's useful to actually hashtag various sort of keywords in there. So tweet benchmarking, just to move on from that, I won't spend too much time on this because I'm already probably going on too long. Look at other people's tweets. If you are a Twitter user or not a Twitter user, get involved with it. But look at tweets and look at what are good tweets and what are bad tweets. And I think you'll be in your own little sphere and your own sort of orbit, shall we say, about who you communicate with. You'll see tweets which you think, oh, that's a good tweet. That's worthwhile. And you'll see some tweets which are too short. Obviously, it's a short message anyway. But you'll think, well, that doesn't make any sense. Or what's the point of that tweet? So try and think of the purpose, really. So it's a nice exercise in your own time to think about what you'd like to say. Think, well, if I was tweeting about what we're doing today, for example, what would I want to say? It could be very nice presentation. Okay. What presentation? You'd obviously structure it so it has some meaning to those who are receiving it. Sentiment analysis, I mentioned this. This is a big, now data mining is one of my things. The data is what I get involved with. And we're leaning into the AI, the artificial intelligence aspect there. And this is another subject, another time really. But the opinion mining, whether it be Twitter, Facebook, or other mechanisms like surveys, respondents send something back to you. Trying to work through that and find some sort of sense about what's being said is useful. It's useful data. It's okay, it's unstructured data, but it tends to give you a feel about the sentiment of what in a sense, the group or the herd are actually saying. So this is useful for customer reviews about various products. It's useful for universities about really things like, well, how do the students feel the course is going? So the tool I use is a thing called Sentiment Viz, and I've just done a little screen grab for you. So you'll find, I'll put the link on the next slide for you. There you go. So this is well worth having a look at. And very quickly, because but you'll see here you've got little pointers. So I can go and find a tweet from that particular day. Okay, I can search, and here's one from me. It's talking about something that I did in November. Okay, November the 12th, and it's sort of picked up the sentiment of my trip to Pembrokeshire, and it will put the sentiment, whether it's good or bad. So was I unhappy? No, I wasn't. It's one of these over here. It's not live, this, so I can't show you which dot it is, but one of these dots will be my tweet. And of course, this could be lots and lots of dots. And in a sense, real time, it's actually showing where, now what of course you're after, of course, is people who are in a good mood, happy. You know, so for your Twitter feed as a company, SME, small business, or individual, what you're looking for, of course, is things in the right box, not upset, not unhappy, you're not angry, but you know, satisfied. So it's like a customer review. So sentiment analysis, nice sort of big part of really looking at data mining, and not just obvious data like product name, product ID. This is something more intangible, really. This is the feeling, what do people feel about that? So intangible data, which tends to give you other reflections or interpretations of what's going on. Other tools, ICT tools, where blogging, I blog. Not everybody, I'm sure. I try to blog. I don't really have much time at the moment. I tend to get involved in a little bit of media work for the radio station. So I blog about what we've been discussing. And I use various blogging tools. I use the blogging tool from Google, Blogger. And if you haven't had a go with it, have a go with it. And it's really like a diary. You blog about things which are going on and you've got an interest in, and people can find it. They can see your blog, you can promote your blog, and you'll gather sort of followers saying, well, that's interesting. So lots of bloggers, there's lots of bloggers for Python, which is the next subject coming after mine. There's often useful forum sites. You'll find them on YouTube as well, all these kind of things. Some are useful, some are not so useful. You've got to navigate through them, decide what's useful and what's not. Other tools I use, SurveyMonkey. I also use the Google Docs survey tool, which you can actually then automate and link to an Excel spreadsheet. So as the respondents respond to your survey, it updates your Excel spreadsheet automatically. So SurveyMonkey are nice and easy to use worldwide. And of course, Google Docs, as I say, has a survey tool within it. Facebook, I use Facebook as well quite a bit, and that's useful from a business point of view, an ICT point of view. You can actually put on here reviews. So this is one of our local builders. These are my builders actually. They're doing some building work for me at the moment, and you can't really see that, but on here on their Facebook page, they've got a review from somebody like myself saying worthwhile, reliable, trustworthy. And that's a useful ICT tool as well. Also, I'm a big VW fan. I've got an ancient VW camper. It's 48 years old, German built, still going. Continual maintenance, of course, but fantastic. And we get out and about with that. And where I get it serviced is this company based in Banbury in Oxfordshire, and they have testimonials. So they're again a useful part of a website, a testimonial about really the experience that their customers have had with whatever product it may be. Other tools I use from a data point of view, I use this tool, Octoparse. They're again freely available. Have a go in your own time, really. I use this for data mining. You can scrape with this. So some of you may know what I mean by that. Some of you think web scraping. You can scrape from the actual browser. So you can scrape material from the browser. So you can go onto a particular site and then scrape the data from that and then store it and then mine through it looking for certain things. And you can link that in through to sort of like a web query. So have a look at that in your own time. That's a tool I tend to use. E-commerce, this is another subject, another time, maybe a subject for a future sort of involvement with the Erasmus Week. Big e-commerce user, e-trading, e-commerce, e-business. Certainly in the UK has almost replaced the high street. We've got a sort of transition from face-to-face bricks and mortar to online shopping. I'm sure that's happening in your own countries as well. So worldwide trade via e-business, e-commerce. This is one of my little simple sites. This is using a tool called Simple Site, which you're welcome to click on. You'll have a look at. There's the link to get to my site. Hanchett. My wife's a big gardener, so we've got like a small space where we grow things. Well, she grows them. I just dig and move soil around and plant things in the wrong places. But so I'm the labour. She plants potatoes, and we have a manure pile which was from our previous owners. They used to keep sheep, and so we had obviously sheep pens, and there's lots of manure there. And we're selling that off bit by bit. So we bag it up, and this is the mechanism where I sell it. I sell it via a little e-commerce site where they can actually go on the site. This hasn't cost me anything. I link it through to PayPal, so it's a freely available, simple site. Hence the term. That's the whole idea of this Danish company's offering. I haven't got to enroll with any money. It's not cost me anything. I get set up. I can actually make it more sophisticated, but of course that would cost a bit more money. So sort of bring that all together really. Here's like a list of the tools, the online tools for entrepreneurs, students, self-employed, university lecturers, etc. Just to sort of go through the tools I use on a day-to-day basis. A lot of them are cloud-based, as you can see. You have to download it to your laptop or your phone or desktop. So of course Google Drive, use that extensively. Fantastic. I use that for backup. My calendar, well, one of my calendars, I have an Outlook calendar as well. So that's really, you need something like that to obviously operate, to schedule, be organized, try and avoid clashes, which is becoming very much a problem with our day-to-day life at the moment. I find I'm continually looking at things and go, okay, that doesn't work. I can't go to that because I've got this. Just going to OpenOffice or MS Office via OneDrive in the cloud. You can do it in the cloud. It's no license, or you can also sort of download it if you're part of an institution, get a sort of organizational license. Zoom, which is what we're using today, wonderful. It's improved no end. There was a few security issues initially, but it's Doodlepole I use a lot as well. I know Costas has been using Menti, which is new to me actually. So thanks Costas. But I also use Doodle.com for arranging things to get opinions about when we could do something, and they can vote on it. So it's like a voting tool. I use WeTransfer for files or QuickFile. Project, big part of what I do day to day. I either use Gantt from Google, or I use Asana. That's a nice Gantt type of tool. So you've got a visualization of your project. Social media I've already covered. For little short videos, up to 15 minutes in length, because of course, those of you who do video on a day-to-day basis, you know that 1 minute of video is actually quite a long time. 15 minutes is ample. So we encourage our students via various assessments really to do a video. I've used that more and more recently with programming modules, either recommended to other universities or what we do, where they submit their file, which of course needs to be run, that they're executable, and I run it in my own environment or on the cloud. But I also get them to do obviously documentation, and also just as a backup, I get them to actually do screen grabs. And also talk about what they've done. Why did they do some things a certain way? And they submit a little video as part of their submission. They don't get any marks for that. It's not about marking the submission of the video. It's just useful if we get a problem. I can look at really how they've gone about something, and we found that's because of course problems do occur when you run things. It ran in their environment or online or in our server space, and then suddenly it doesn't run for some reason, which of course is the history of programming. I also use Calendly to people can book some time with me. I just have that as part of my email signature, and they can say, right, I'd like to book a half-hour meeting with you, Jonathan, and they can just book it online. They can see my calendar essentially, and they can book a slot, and I don't have to do any work. I just, somebody's actually booked a slot. Fine, they know it's free, that slot, because of course it's on the calendar. So in a sense, it's self-service. I also use online banking, and of course in the UK, just like other countries. Yeah, I was. You've got government gateways. I went to Kefalonia last month, and of course, Greek government, bless them, had made it very easy to do my passenger location form. Actually, better job than the UK government. I was able to go online, put where I was travelling to, etc., all via their gateway, all secure, brilliant job, and I was able to get to Kefalonia and back without any problems at all. PayPal, some sort of payment mechanism. That's what I use. I have a business account for that, and that links through to my things. I'm going to have to do a couple of more minutes, and then I'm done. Right, finally, very finally, a kit list. The cloud has worked in our favour. You need to have something on the move, so something like obviously get a decent smartphone. It doesn't have to be the latest. I've got the Samsung S20, I think it is. So I upgrade my smartphone on a regular basis. If, for example, in the UK, we've got this COVID test and trace system. So we've gone for eventually, it's a long story, Apple and Google type of derivative. But of course, unless you've got a fairly up-to-date mobile, you can't actually download the app. So my wife can't download the app. I can. It doesn't work on all the devices. So that's been a problem for us. So it's almost like you've got to upgrade really to keep in touch. Some sort of laptop, whether I'm a big MacBook user as well, so I'm not completely Windows obsessed. I don't have a printer. I don't use printing. It's all gone. I don't have a printer in the house or at work. I just actually try and do everything electronically. And I carry with me all sorts of cables and VGA converters just to make sure I can actually connect to things. Networking, final point really, networking. And with the ICT tools, you can also link that to your networking group. So I'm part of the British Computer Society. There's other organizations like IET for engineering. And we do things like meetup.com, where you can arrange meetings and get together like a networking meeting. How do I find work? Very, very quickly, because I'm running out of. The site I've used recently is nextdoor.co.uk, like a community website. And that's where I've put my manure website, so they can actually find it. I don't want to sell outside my own little sort of patch. I'm not interested in delivering manure. I might sort of send a bag a mile down the road and deliver it for them. But really, it's about sort of local socialization. And that is a run through of all my slides. I've had to speed up a little bit at the end there, so apologies if I sort of went through a bit too quickly. If I can invite any questions, there's my email address. You're welcome to email me. You can tweet me if you've not used Twitter before, or you do use Twitter. Tweet me. I'd love to hear from you. There's my LinkedIn profile, which you can obviously follow. You connect with me. I'll be delighted to hear from you. And I'll take any questions. Thank you very much.
Thank you very much, Jonathan. You forgot to mention that you're a friend of mine, so they can be connected through through myself. Sorry, I'm kidding. Thank you very much, Jonathan, for the nice presentation. And I have to say, I'm feeling very bad for myself, because for all the tools that you have presented, I pay annually. I pay annual fees for each one of these tools, or the majority of the tools that you're using. So
time to decouple.
Probably, in Greece, we used to say about the American tourists. So probably I'm one of them. So any questions from the audience?
I'll just stop sharing.
Yeah. Okay, let me see, because we have a question from Marius. Doesn't GDPR, General Data Protection Regulation, affect data mining?
A great question, Mario. Yes, it does.
Who is Marius? I would like to see Marius. Sorry about this, Jonathan. Where is Marius' camera? I would like to see who is Marius. Oh, Marius is very shy. Okay, let's go.
I can't see Mario. Well, is Mario still with us?
He does not have a camera. Okay, I just.
Oh, right. Okay, Mario. Yes, that's a very good question. And I'm sure, like me, you see day-to-day infringements of GDPR. For example, I had an email yesterday where all the email addresses were actually put on your one email and shared with all the respondents. Of course, that without their permission, in a sense. So it's all to do with permission, really, about the data which is available. So if it's been authorized to be published and it's got permission, of course, then really it's data that can be mined. If it's data which has been gathered in a rather covert way, then of course there is a question mark about that. So as you know, the GDPR regulations in the UK, I'm sure you've got the equivalent in your home country, quite complex, really. And to give you an example, with the BCS, my society, my professional group that I'm part of, we were so stringent about the data GDPR that we're, as a branch, I'm part of the North Staffordshire branch, we're not allowed to hold the database of our members who live locally, which of course we've complained about, because we want to contact them. We want to know where they are. Now, of course, I suppose we know in a sense that where they might live. They might be in Crewe or Stoke or Newcastle, one of the local towns. But we're not allowed access to that because the BCS are so careful about obviously maintaining the data in a centralized way. And of course, this has been the debate about test and trace. There's this balance about how do you trace people and and balance that against their privacy. Do we go for full-on tracking? And I know some countries have done this. I think Korea are doing that, where they're tracking everybody and all their details are known to and made available. Or do we go for something where there's a balance between privacy and sort of ease of use? So the quick answer to your question, I think, is yes, it does affect it. It's in various levels and depends on the type of data. So that web scraping example I gave you, that's stuff that's in the public domain. They publish the web browser. So I'm quite permitted to actually scrape that data and navigate through it. I've mined the data. But if I access the file, say I've accessed something at HMU via whatever directory I've got to, and I've not been given permission to that, I've really accessed that file improperly, and of course then I'm infringing the GDPR regulation.
Thank you, Jonathan. And I would like to inform all the students. I can see that Marius he had a lecture today about GDPR. That there is a fantastic free course on GDPR from the Mathesis online course platform. Mathesis. It's like an online platform from the University of Crete. You have just to register. I will send to all of you. It's like EDX. It's like the Greek version. It's Mathesis, and the course is for free. It's something that I will follow. If you go to this platform, then you will find a whole course, a series of courses about GDPR. So thank you, Marius, for the question and also for participation. This is like what I want, from the students, just to ask as many questions as possible. And this was the first one. This is a progress, and I'm very happy. Any other question from the audience? So before the questions, they will come. I have one, Jonathan. You mentioned about MailChimp. Do you want to elaborate? Because I'm monthly. I have a subscription in MailChimp, and mainly I use it in order to build my newsletters. But I have a subscription. I know that the base to my subscription, I can access 500 different emails or 100 different emails. And I have realized right now, in order to register emails within my contact emailing list in the MailChimp, I should ask them first, because GDPR is like probably because of the GDPR, someone can be very angry. But you mentioned another function of the MailChimp. Can you please elaborate a little bit more? What things I can do with MailChimp apart of the newsletter and sending? Did you mention, I think, about group emails that you can send?
I mentioned that I use a thing called Doodle, like a voting tool. So I use Doodle, a thing called Doodle, where you can actually set up a set of questions, and then people with radio buttons, for example, and then people can express either a day they want to visit or a subject they really want to. So if we were doing, for example, your topics for next year for the Erasmus Week, argument's sake, you could do a Doodle poll where you'd say, right, okay, what would you like to see in the schedule over the 4 days? And people, you'd have a list, and they'd click on various radio buttons. I know you've sort of done that via email really over the years, but it would be like a voting tool. You say, right, okay, out of say 100 contacts, 60 voted for a topic on e-commerce, for example. And then with bulk. So that's really, I think Menti's got that same sort of feedback thing, but it's not really. Obviously it's a vote. In a sense, they are voting. They're giving you some statistics about really what they feel about what you've asked them. Whatever the question is. So that it's, and as you mentioned, Menti, like a lot of these tools, really, there's like the basic version, and you've got a more sophisticated version. But so basic.
I would say to you, if you pay a subscription, the tool is much. I mean, it reveals all its function and something else. Yeah. But here is the Greek drama. I pay subscription for Doodle. I pay subscription for MailChimp. So probably I double pay. Since I could do the job in MailChimp.
Maybe yes.
Anyhow, Any other question? I think that it was a very nice list of tools that we can use, and we would like to thank Jonathan for the presentation and also for supporting us. It's one of the most, how can I say, faithful veterans in what we are doing. So thank you, Jonathan, very much. It's time to move to our next speaker. Our next speaker is Professor Jürgen Koch from the Department of Fundamental Basic Sciences from Esslingen University. I have realized that Esslingen is very close to Stuttgart, and there are very large, and this is something that Professor Arndt also mentioned, Jager also mentioned, that there's a Greek community, a very big Greek community there, and a very big Orthodox church. So thank you very much, Professor. Also, Professor Koch is a member of the administration and management of the University of Esslingen. So the floor is to Jürgen. Do you allow me to call you Jürgen? Okay, thank you. And the floor is yours, and the people are looking forward to learn from you how to make simulations using Python. And we will have also Jürgen with us in our webinar in mathematics education. All right, so the floor is yours, Jürgen.
Kostas, thank you very much. Thank you for the invitation. And thank you for this feeling here. I feel a little bit like in a radio station. You're sitting on the opposite side of the table, and he switches his microphone off, and I switch the microphone on.
But I'm not going to interrupt you. This is the last time I interrupt you.
Okay, so I would like to open my screen for you.
Okay. You can share, yeah.
Okay. Is it okay? Do you see my screen? Okay. So, okay. To enlarge this a little bit. So let's start. So my name is Jürgen Koch, as Kostas already mentioned. I'm a professor for mathematics and computer science at the University of Applied Sciences in Esslingen. And yes, I would like to talk a little bit about modeling in simulation, especially with Python. Let me say a few words about Esslingen. Esslingen is located in Germany and the center of Europe. It's about 20 minutes away, as Costa already mentioned, from Stuttgart. For us, Crete is easy to reach as there are direct flights between Stuttgart and Chania. So Esslingen is a small town. It has slightly less inhabitants than Chania, but we also have a very beautiful medieval old town. Yeah, the headquarters of Daimler, Porsche, Bosch, BMW, and Audi are close to our university. So most of our study programs have links to the automotive industries. There are two important institutions in Esslingen with a long tradition. In fact, our university and Kessler. Kessler is Germany's oldest champagne producer. Okay, we are not allowed to call it a champagne producer. As you may know, champagne is we are not allowed to do this because Esslingen does not belong to the Champagne region in France. And by the way, our university, Pavla, if you are still with us, we are EMAS certified. Yes. Okay, now let's focus on the content of my talk. First, I would like to give a short introduction to modeling and simulation. Here I would like to figure out the advantages and objectives and I would like to explain the simulation pipeline.
I think that you should place the full screen motion. And because the people, they can see the letters are very small. If you go there, yeah, press this. Now it's much better.
It's much better?
Yeah, yeah.
Okay, okay. Yeah, I tried it. Okay, sorry for that. Yeah. Okay. So yeah, what's the content of my talk? First, modeling and simulation. Here I would like to explain the simulation pipeline, give you some classification about modeling and simulation projects. Then I would like to show you in more details the student projects, a typical lecture for IT students, so computer science in the first semester. And I would like to go into details on four different projects. The first is called Project Robot. The second about the traveling salesman problem, the TSP. The third one, quarter car suspension, and the last one, water waves. And so in the last aspect would be to talk a little bit about Python and Jupyter notebooks. Okay, so when we talk about simulation, there are a lot of buzzwords. So scientific computing, high performance computing, HPC, advanced computing, computational science, computational engineering. This is everything more or less the same. There are buzzwords for modeling and simulations. There are different fields of applications. Yes, as we all know, as scientists, science is an application for simulation, but also engineering, economics, and entertainment. And perhaps last, I forgot to mention, yes, medicine, as we know since Corona simulation. Okay. What are the advantages of simulations? Experiments could be hard to or even impossible to realize. This is the first advantage. Experiments could be more expensive and take more time. And third, experiments could be dangerous for humans or cause environmental damage. So I have included a few videos into my presentation, and I would like to show you a first video. The first video is a simulation of the Mars Science Laboratory mission. It is a space probe mission to Mars, and it was launched in, I think, 2011. This gives you a short impression on how many simulation is done for such a project. So this is not a movie. So it's not all what you can see here is real simulation and visualization. This means it's based on calculations and physics and technical stuff, mathematical equations. Yeah, so it's not a science fiction. This is in some kind real simulation. Okay, the last part of the video shows the landing. The lander is called Curiosity. Yeah, and I think it's really amazing. It's just simulation and visualization. Yeah.
In the old days, the simulation was just like, small graphs, like fantastic graphs.
Yeah, the graphic is fantastic. Yeah, yeah, but this is all part of the simulation pipeline. Okay. Prepared to land. And even the mechanisms for curiosity to land are part of the simulation. You see this, and okay. Okay, but by the way, I really like to include those YouTube videos into my lectures, because I think, yeah, always learn from the best. Okay, but so far it's, I think we are set up with this for just a few seconds. Okay, I'll stop it. So the next example, this is really one of my favorite YouTube videos. It's about earthquakes. I mean, again, learn from the best. You can see this video is from Japan. So they have serious problems with earthquakes. And so they do a lot of research on this topic. I mean, Crete is always...
Yeah, I mean, Greece in general.
Greece in general.
We have a great experience in that.
Okay.
A very shaky place, I would say.
Okay.
It's amazing because you can train your students using all these videos and all these simulations.
Yes.
And especially for this blended, flipped classroom approaches.
Yeah, exactly. That's what Kostas mentioned. It's really for flipped classrooms. Those videos are really a good tool. Okay. Okay, so I think it's okay for you. So I have integrated the links to the YouTube videos. They are a little bit longer, and you can check those videos if you are interested. So modeling and simulation, what are the objectives of simulations? I have 3 different objectives here. So first one is optimization. This is a simulation from Audi, the so-called crash test simulation. And what does it mean, optimization? So optimization means you have already a product, like a vehicle here, and you're trying to improve it. Yeah, you're trying to improve it in some way. And for those reasons, optimizations are done mostly by simulations nowadays. Yeah, you see, you can have a view inside the car, or you can watch more details, and you see all this happens in milliseconds. So if you would like, if you would do the experiment with this, it would be very hard to have the equipment, or only the car structure. Okay. Okay, I think it's okay with this video. So the second objective is different. It's called causal analysis. And again, I have an example for you. This is the so-called Millennium Bridge in London. They opened the bridge in the year 2000. And this was a big happening. I'm not sure, was it related with the Queen's birthday or something like that? I'm not sure about that. But it was a big happening in London. And but it nearly ended in a catastrophe, as you can see now in this video. I will proceed a little bit further. Yeah, here you can see it. So the bridge had a frequency, a base frequency of 1 Hertz. And so all the people on the bridge, they moved with 1 Hertz frequency, and this nearly caused an accident. So third objective, this is forecast. So we all know those kinds of forecast, climate forecast, weather forecast. And this is actually today, this is done more or less automatically. There are big institutes who provide those kind of simulations every day. Okay, a little bit of classification. They are deterministic or stochastic models. Deterministic means not based on random processes, and stochastic means based on random processes. And on the other hand, there are discrete and continuous problems. So typical continuous problems are based on real numbers, and discrete problems are based on integer values. But I think, to be honest, it's not so important to distinguish, because most continuous problems will be reduced by discretization to discrete problems. Okay, this slide is just to show you the simulation pipeline. The simulation pipeline starts with the modeling. Modeling means you have to explain what you are going to simulate. In this case, in this example, it's a Mercedes-Benz AMG, the active body control of this car. You can see you need some physical, technical descriptions. This is called numerical treatment. And the numerical treatment normally results in some mathematical descriptions, some equations, like here, ordinary differential equations. And then you have to solve the equation with some kind of implementation. I've put here on this slide a few lines of code in Python, and Python is able to do calculations, symbolic calculations, and numerical calculations. And then at the end, we need some kind of visualization. Yeah, this is here my student project. It's not the AMG active body control. It's a small. It's a reduced model. And at the end, we need some kind of evaluation. Evaluation means, does the result fit to the model? And the last step is embedding. So embedding means to make it a part of a software product. Okay, now I would like to switch to my students' projects. So I would like to explain a typical lecture for IT students, and then 4 different student projects. So what are the preconditions for this lecture for IT students? They should have a basic knowledge in mathematics and programming. Normally we do this modeling and simulation in the 3rd semester. So they have 2 semesters in mathematics and 2 semesters in programming. What are the learning outcomes? Students learn to develop software for simulation. So this is very important. So our focus is not on using some simulation tools. So I'm teaching IT students, computer science students, and they should learn how to develop software for simulations. My learning method, students work in small teams on different simulation projects. So I would call this just learning by doing. Okay, my first project is called Robot. This is a simple simulation project. The student, they will learn that the difference between direct and inverse kinematics. They will learn about path planning, about collision detection, and the working envelope of a robot. Yes, by the way, this video was produced in the production line from Audi. This is not far away from Esslingen. Okay, so next project, I call it Robot. You see, this is a very, very simplified model of a robot. On the left, this is the result of the student project. On the right, you see the technical drawing, and with this formula, it's easy to see that the direct kinematics can be calculated. If you put in some angle alpha and beta, you will get the resulting position for this coordinate t. Okay, how does it work with this student task, this student project Robot? The interesting part is the so-called inverse kinematics. So you fix a position for this little red sphere, and you have to find out the angles alpha and beta, and this is called the inverse kinematics. For a more enhanced robot, this is a little more challenging task, but for the simple robot, it's really easy to do. Here the student task, task 5, inverse kinematics, implement the function, test the function with the point t located on the baseline exactly between O and the obstacle, print the corresponding values for alpha and beta. And here is the solution. Again, just a few lines of code in Python. Because Python together with NumPy is a very easy system to do programming with matrices. Okay, so the third project that I would like to show you, this is called the TSP, the traveling salesman problem. And again, this this video, I would like to introduce this project by a video. And I think this video, I will call it the Ronaldo of TSP videos to keep on with the lecturing this morning. Okay. Do you get the sound?
No.
So those of you who are connected with the net, so go to the link, open the video in YouTube, and you'll get the sound with it. So it doesn't matter. It's no explanation. I will explain the steps. I will explain the TSP step by step. So what are the learning outcomes from the TSP? I would like that the students understand the computational complexity of optimization problems. They should understand the problem of local versus global optimization and the principle of simulated annealing and Monte Carlo simulation. So now the system is going on, yeah, with this so-called simulated annealing. You see all those cities in the United States. I guess these are more than 300 cities, and it's really hard to find, to solve the TSP problem. Oh, by the way, I didn't explain the TSP problem. The TSP problem is to find the shortest route between given cities. So we have here 304 cities and 2 times 10 to 624 possible routes. Okay, so let's switch on to the next one. So I have prepared a question for the students. So suppose we have just 25 cities, not more than 300 or something like this, just 25 cities. And we are able to use the fastest computer that we can access so far. Fastest computer, you can check this on www.top500.org. So in June 2020, on the first, ranked number 1 is the supercomputer Fugaku. And so you know how fast this computer is, and you are able to find out how long it would take to try out all possible routes. Please write down your guess on a paper or whatever, and I will proceed with a short explanation on that. Okay, it's really some simple math. You have 24 times 23 times and so on times 3 times 2 times 1 different possibilities. For each possibility, you need to add 25 numbers. This means 24 floating point operations. Then you need 1 floating point operation to compare with the best result. So in total, it's a factorial of 25 flop that we need. So what is the speed of computing? This is the speed of computing. The R peak is 5 times 10 to the power of 17. And the speed is called in flops per second. And you need approximately 30 million seconds. This means 1 year. Yeah, so this is the computational complexity of the problem with just 25 cities. So you see, many students think that we can do the thing so good during the last few years because our computers are running so fast. I think that's not true. We are proceeding because we have developed better algorithms. Okay, so here the problem of local and global optimization. The greedy strategy is very simple. Specify arbitricity as the starting point, like I did on this slide. I started in Aachen and then proceed to Köln, Essen, and so on. But you will have a problem here in Hamburg. Hamburg, closest to Hamburg is Lübeck. So you would proceed to Lübeck and then to Kiel. But then you have a problem because you get a crossing here, and it's easy to see that if you have a crossing, this is not the optimal route. So this is one very good example. You do some local optimization, always go to the closest city, but you don't end up in a global optimum. Okay, as seen in the video, how can we find a better solution to the problem? We do a randomly edge swap, like here. A random edge swap is very easy to program since we have just to switch the direction of a few indices. This is very easy in programming. And we combine this with a second random process we randomly accept longer routes. Yeah, why do we do this? We do not want to get stuck in local minima. So the red points are the local minimas, and what we are going to achieve, what we are trying to achieve is the global minima, this green point. And therefore we have to sometimes climb up the hill, so accept longer routes and then proceed. Okay, so next student project is the quarter car suspension. Here I have prepared a video to show you what.
If you pause the video.
Yeah.
Stop sharing and sharing again. During the sharing, you have the option below to share the audio as well, if you would like to share any audio anymore.
Okay. So Kostas gave me some introductions on how to share the sound of the video, yeah. But I don't have sound with this video. Yeah, just the TSP would be nice to have the sound. All the other things are really good without the sound. Okay, even if we are in the radio.
Oh, yeah.
But I cannot provide sound. Okay, so what is the impact of this project? It's the simulation of vehicle dynamics. It consists of numerical and symbolic solutions of ordinary differential equations, as we have already seen, and the real-time simulation of different test tracks. So I will skip the details on this project since I already talked about this a few minutes ago. Okay, so my last student project that I want to show you is called Water Waves. I will start the video. Let's see. Yeah, it's just very simple. Throwing a stone in the water. This seems to be the most simple simulation problem if you compare it to the other things. But as we will see, for a simulation, this is a very complicated problem. And I would like to explain you why this simple experiment is so hard to simulate. Okay. So what are the learning outcomes? Simulation of the propagation of waves in shallow water, numerical treatment of partial differential equations, and this always includes some stability and stepsize analysis.
The whole physics book, the whole physics course is to be simulated.
The whole physics, yes.
Sure.
Thank you, Kostas. Yeah, he mentioned the whole physics is included in this one project. Yeah. So if you are going to think about the physics a little bit more in details, you will soon end up with the Navier-Stokes equations, and this is only the most simple representation. The most simple representation includes just three equations. H denotes the height, U and V are the components of the velocity. And so if you think a little bit about the Navier-Stokes equations, why are they so hard to solve? So let's jump on the right side of the slide. The Navier-Stokes equation, they belong to the so-called Millennium problems. In 2000, the Clay Mathematics Institute declared 7 problems to the so-called Millennium problems. And whenever someone is able to solve one of those problems, he will get $1 million from the Institute. And as some of you may know, one of those problems is already solved. This is the Poincaré conjecture. This is it was solved by soon after 2000. I think Perelman sent his proof in 2003 or 2004. And in 2017, he was declared as the one who solved the problem, but he rejected the money. He was not interested in this 1 million. So, but if you're still interested in $1 million, the other problems are still open. So, but how to proceed with the simulation? That's not a big problem because we are dealing with numerical analysis. So we have to transform the Navier-Stokes equations with a suitable substitution into a hyperbolic system and then solve the system numerically. So what is, how can we solve such a system of partial differential equations? I think Lax-Venthrov is one of the most famous methods to solve this. And as you can see on the right side, you need some kind of discretization. You need the grid in X and Y direction, and the grid in the third direction is the time. And the important idea of Lax-Venthrov was to proceed in half steps. This means you calculate some values in between the grid point that you originally fixed. Yes, those are called the half steps and the half points. Okay, I do not want to go into more details, but as you can see, the simulations of my students, they will end up with the simulation. So the stone is thrown in the water and the waves comes here we are dealing with a basin. So we have reflections in the corners and on both sides. Yes, this reflects the wave again. Okay, so just 2 slides. I would like to talk a little bit about Python, as I already mentioned. So why do I think that Python is so important? Actually, not only for computer scientists. I think it's really every technical engineer should learn a little bit of Python. And why do I say this? I say this because it's really, really simple. I do programming with Python with kids at school, and they are able to learn it in a few hours. So I guess every engineer should be able to learn a little bit of Python. There are large libraries of toolkits, NumPy, Matplotlib, SymPy, Pillow, and so on. And actually about more than 25% of all programming projects are related to Python. Why is this so? Why? Because all the other programming languages can be easily integrated into Python. Python is used for data science, artificial intelligence, and financial services. Many popular applications are written in Python, like Google, YouTube, Instagram, Spotify, Dropbox, and so on. Okay, so here on this slide, I have prepared my last video. And here I would like to introduce a framework. This is called Jupyter Notebook. This, I will call it a software environment for scientists. It's a web application to create and share documents. So as you can see on the right-hand side, here you have some kind of documentation. F depending on X is a function with sinus X divided by X and so on. And you can see you have the documentation and the programming in one single document. And all this stuff is located as a web application, so you do not need to install some software on your computer. You can use it online. So you have live code, equations, visualizations in text online in one document. The Jupyter notebooks are not only able to handle Python, they are also able to handle other programming languages. And I just perhaps, do we have a little bit time, Kostas, by the way? Yes?
How much time do you need?
2 minutes.
Oh, you have more time. You have 5.
I have 5. Okay. So here, I guess you do not hear the sound from the video, so I would like to explain what's going on. So if you open a Jupyter Notebook, the easiest way is go to Google Colab, and the first thing he did is change to a markdown cell. This means he does not want to program in this cell, so he just want to put some documentation into this cell. Okay, documentation, markdown cell. And because maybe some of you are familiar with the LaTeX syntax, the LaTeX syntax is used for equations. Yeah, $2 means we are starting with an equation, fraction, sine x divided by x. And then we evaluate the cell, okay.
We have a message from Jonathan Wesley. Love Jupyter. We use it as well. Thanks, Julian. So you can reply. They cannot listen me. Only.
Okay.
So probably you can say thanks to Jonathan and whatever comes.
Yeah, Jonathan, thanks for your comment. Yeah, I like Jupyter notebooks and Python too. Okay, so the next cell he started here. He started with code. So include some kind of library. It's called a matplotlib library. And then the next library, it's called NumPy. This seems to be a little bit cryptic at first start, but in general, I just use cut and paste and from another project. Okay, now he starts with the number pi, and then he generates a sequence of x values starting from -4 times pi to 4.pi. 1000 values and so on and so on, and he will plot this one. Okay. Okay, I think this gives you a first impression how easy it is to work with Jupyter Notebooks and Python. So I'm done with my talk. 2 lines of conclusion. I think learning by doing is a good concept to teach students the basics of modeling and simulation. Jupyter Notebooks and Python form a framework with high acceptance by students. This is my conclusion. And thank you for your time. And I would like to see you in Esslingen soon. Kostas, it's yours.
Yes.
Thank you very much. You should mute your microphone. That's why I was waiting. So, all right. No, let me. I have done it. So thank you very much, Jürgen, for the presentation. I have to say that I have very much impressed by the quality of the simulations that you have generated, and I'm pretty sure that Python also is responsible for such high definition simulations. You know, when we were doing simulations during my PhD, and we were designing laser cavities and how the beam can propagate. It was just like different colors and 2D kind of diagrams and images that we get. So I was very much impressed, and I was thinking that I should learn Python, but I don't know how easy it is for someone that does not know how to program to learn such a tool. Do we have any questions from the audience? I'm expecting, people that they are using, programming and simulators. If they have some questions to ask Jürgen, the floor is yours. I don't know if we have anyone that has any questions to ask Jürgen for this, or any kind of help, or any other kind of collaboration that you can have. I mean, I think, okay, Alexandros Zakroglu, a student, thank you very much. Is it Jupyter Notebook free?
Yeah, so
You should unmute.
Is my microphone?
Yeah, you can unmute yourself. Or let me, I think that you can unmute yourself. Where are you? I should find you now.
Yes, I got it. So thank you for the question. Jupyter Notebook is free, so it's no problem to use it. So I personally, I don't. Normally I work in a local installation. It's called Anaconda, the Anaconda framework. This is available for all systems. It's you can use it on a MacBook, on Windows, and Unix systems, and it's absolutely free. Does this answer your question?
Let's give some time to Alexandros to reply. We have another question from another student, Orestes. Thank you very much, Orestes. Is Python code also producing the animations, or the data is exported and used in another softwares?
No, this is very important for me. So Python is the whole system. You do not have to integrate other tools. So in general, you have tools for 3D visualizations. They are all called Python bibliotheques, but they are all free and can be easily integrated just into Python. You do not have to install something. You just say, like I showed with the Matplotlib, so I can integrate it in the code and load it and use it.
Thank you.
Oh, next
Jonathan.
question. Yeah.
Jonathan, you can switch on your camera and your microphone, and you can interact with us lively. Let's check if Jonathan is with us. Okay.
Yeah, that's always the problem between version 2 and version 3. So there are lots of discussions in the web. You are right, Jonathan. Thank you for that. But I was lucky. I'm a Python late runner, so I started just 1 year ago, and then version 3 was the state of the art, and I never tried things with version 2 and so on. So I don't have this problem. Yeah, but from my students, I know I had a few students with project in the industries who had to switch from version 2 to version 3. It's not a big problem. You know, everything that worked in version 2 could be run in version 3.
And I would like to ask, I think Nikos Petrakis is doing programming. Before I will jump to Maria Zakinthinakis' question, Nikos, do we teach them Python?
A few years ago, I have taught a class of students in a lab doing some kind of mathematics with Python. Not Python itself, and of course, we didn't use any other libraries like NumPy or what else. Only simple mathematics like statistics using Python.
Okay.
Of course, arrays, vectors.
Let's move to Maria Zaki. Thank you, Nikos.
Interesting presentation.
Thank you.
Let's move to Maria Zakintinakis' comment. Python not only has incredible possibilities, but fortunately is extremely easy to learn. My 12-year-old boy is competing me in creating Python code. I strongly recommend Python to everyone. I'm feeling I don't have the capability and the mental ability of a 12-year-old, kid.
Oh,
thank you, Maria, encouraging us.
Yeah, Maria, thank you. That gives me another very interesting point. I have a project at my university. It's called the Girls Digital Camps. And we do programming with the girls at school. They are in the age from 10 to 15. And we learn them Python. And I agree with you. It's really no problem for the kids to learn Python with the age of with 12 years. So thank you again for your support.
And can I ask you, is the Python a free software or we should pay?
Python is all free.
Okay.
It's all free. And oh, by the way, let me check this. I could send you a few links on how to learn Python, because I think one of the best MOOCs. Yeah, we talked about MOOCs today. They are about Python. I'm not sure is it Stanford or Waterloo University. I should check this. But my students, they just learn it online by going to those MOOCs.
And what is the fundamental knowledge that you should have in order to follow these MOOCs? Nothing.
Nothing. That's the best point. Yeah, it's nothing. It just starts. Why should you learn programming? And this is the first question to be answered. And if the students understand why you should learn programming, then the second one is, and why should you do it with Python? Okay.
I think that in 2 months from now, I will call Maria Zakintinakis-san to speak each other about Python. To teach me, because I will be in a much better level. I have a comment from Alexander Zrakoglu, another student of us. EDX is a good option for learning Python as well.
Oh, so I don't know. I don't know.
EDX is the platform of MIT, of MOOCs.
Okay,
So,
okay. Oh, okay. Yes. Yes.
Any other comments? I think that Jürgen, you were the champion, because it's you that the majority of the students ask questions. So congratulations.
Okay, thank you for that. Yeah.
I really appreciate
Κώστα,
it.
το μικρόφωνο σου είναι κλειστό.
No, yes.
Because I can listen myself to the microphone of Jürgen because it's next to me. So the first comment that I mentioned, I like that Jürgen. So Jürgen, you should switch off your microphone now.
I will do this. Yes.
I said to Jürgen that I'm very glad that he told me that I don't need to know anything in order to learn Python, that this is very encouraging for me because I know nothing about programming. So I will start with Python. I was very much impressed. I think it will be very useful for my physics course. And also I mentioned that if I do my best, probably I can speak with Maria Zakintinakis-san in order to be able to speak his language about Python. So thank you, Maria, and thank you, Jürgen, for the nice tips. And probably I should advise my friend Jonathan Westlake about Python if I have some questions. There are some great examples on the raspberry.org about Python. So I don't know if you would like to comment something. You should switch on your...
Yeah, for me personally, I know this page, but the Raspberry is very good for kids because it's a really cheap solution, and but I'm not experienced on it.
Please switch it off now again. So we would like to thank Jürgen again. As I said, Jürgen was the champion because you have received the most of the questions from the students. That's why I will give to him, you know, the first edition of our t-shirts from the International Relations Office, Hellenic Mediterranean University, made by Armani. Armani, not Armani. But thank you very much, Jürgen. Thank you very much for all the participants of today's day. This is the end of the third day of our International Relations Office. I would like to remind you that tomorrow, the whole day is devoted to 5G. We will start with a contribution from Algeria. I don't know if the colleague is still with us. Let me remind his, the first contribution starts 10:15 from Dr. Afgou Riyad from Algeria. I don't know if we have the colleague with us. He has been logged in, you know, before. So we will start with this contribution about 5G and the application of 5G mainly in education. And then we have, how many? Like 5 hours of 5G applications from, I will say, top experts from Greece and on abroad. We have speakers from companies, speakers from academia. I hope to have it with you. You have to send me an email in order to register to you, you know, through this webinar. And please, I will send after we end this session, the Zoom link for tomorrow. If people, you will not receive my Zoom link within the next hour, please contact me again in order to send it again. So thank you very much for your presentations. I will upload also today's video in our YouTube channel, and I will send you the link. Thank you very much. Have a nice night, and we will continue from Hellenic Mediterranean University in about 1 hour and a half with our symposium with Dr. Fitilis. So see you, have a nice night, and see you tomorrow, 10:15 or 9:15 CET time. So bye-bye.
Thanks, Kostas.
Bye.